Yo. Oh, damn.
Hello, motherfucker.
God damn it. Where am I? No, don't tell me this. Don't tell me this. No, oh. Okay, I is here. I is here. How thy be? Neon 1, Metal the Legendary, Windsonger, Sharp Vial, Feudal Ed, Freedom Holland, Fermia's Bandersnatch, Cinderella, Alvi. How y'all doing? I have a surprise for you guys. Have you ever... Lupo? Hey. I did get hacked actually. They let me free because my dog called them and told them that I needed to go to the bathroom, that she needed to go potty, so the hackers that actually kidnapped me, okay, I thought that sounded funnier in my head, and then I said it and I was just like, no. Anyways, as I was saying, I have a surprise for you guys. Are you ready for the surprise? Let me open my stream deck. I don't know if it's gonna work right off the bat. Let's see. BAM! Hey guys! How's it going? Yeah, you guys can see me from multiple angles. Isn't that weird? Yeah. Yeah. Yeah, this is kind of strange. This is kind of weird. Yeah. 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 Anywho, todo bom, Jackie. Bom dia para todos. That sounds really good, Felipe. I'm glad it was a good day. Eating rice in Lauganma. In Lauganma? In Lauganma. Okay. Anyways, guys, don't forget that you are always streaming your screens. Private info. Yeah, like don't look here. This is private. Yeah. My Neon 1, thank you so much for following. Okay, the stream deck is working. Okay. Maybe, do we need some light? Maybe I need to turn the light on. Oh my god, I just gave you guys a backseating pass. That is not good. Yeah, you see, oh. It's not working. It's not working. Why is it that it's not working? Oh no. Oh god. That light is bright. What? Why isn't it working? Okay. Anyways, now you guys know what I'm fiddling around with. Anywho, I don't know how comfortable. Yeah, we got triple monitors, Groud. How much landscape do you have? Do you work from a laptop? I'm a dev. I slowly built up the monitor landscape scraping. Okay, now it works, guys. Look. We turn it off. Oh, it's okay. We turn it off. We turn it on. We click the button. We click a. That's. Oh yeah, I have to let Discord know. Oh, now you guys are seeing what I'm doing now. Oh no, this is dangerous. Oh god, Inception. I'm watching the stream on my stream. Okay, this is kind of strange for me, honestly. I don't know how much longer I can go on like this, honestly. Okay, announcements. We live, bro. Great. Need another camera from the side. I want to go full zoomer. Are those open back headphones? Open back what? Yes. What headphones do you have? Me with GeForce 90M laptop. Yeah, I apologize. Oh my god. Anywho. Yeah, guys, we're gonna do some shading stuff. By the way, I was on Twitter. And I tagged Groud. Because there's this old tile map. I was going through my clips because I had to make some shorts. And I reminded myself about the old Godot 3.5 tile map. That was actually 3.4. I don't know how we survived like this. I know the 4.x tile map isn't perfect, but I also think that sometimes people tend to forget about how tedious some parts of the 3.x editor were. This part seems to be a consensual improvement in 4.x. I'm quite happy for it. Thanks for the shout out. Woo! You deserve it. Andre, thank you for the sub. It is like that for 3D. You should go back to I don't think Groud's in charge of the 3D one. Sub nurse. I think the new tile map is fantastic. The only minor issue comes from setting up some parts of the tile set, but that's minor compared to how... Don't know what you're talking about. What's up, Mystic Monk? I guess that face says everything. Yeah, sure does. Loved your devlog. Thanks, Code Red. Thanks. Probably not here. Aww. Trying to summon Slater. Lol. Blue map. Sup? Out question. Do you know how to get custom data from a tile? I looked at your documentation, but it sounds like it's a horrible thing to get. I made a video on getting custom data from a tile. So I will link you that video. Ah. The board onlooker. So here is the video. Using custom tile data. Bam. Badam. Sub to David. How are you here from Gideon? Didn't he delete all of his videos? Oh, or you were here from a while back and now you returned. I feel kind of strange not having privacy anymore on this monitor. I miss my privacy there. You guys want to see my office? This is my office. Just don't look out of my window. Look at that. It's my kitchen. The kitchen is right there. Wait, let me... Wait. Everything is getting tangled. Alright. Can you guys... Yeah, I think you guys can hear me. So yeah, this is the setup. Wait. One moment. Oh god. Okay, I messed everything up. One second, guys. Okay, I think now you can hear me, yeah. So, this is the office. I have my plans. There. Let's turn this off. Okay. Yeah. Plans. bookshelf, mushrooms, and heater, guitar, computer. Yeah, so that's where all the magic happens. Where's the leather couch? Oh my god. 3 monitors, what kind of luxury is that? That has been built up between the 4 to 5 years I've been a dev. I started off with a laptop. Okay, this video's unlisted. Let's... Yeah, there was no audio, but now there is. Hi guys. I'm just gonna wear this hat for today. I hope you guys don't mind. So yeah, 3 monitors. Luxury, eh? That is very luxurious. Let's look back at what my setup used to be. Okay, guys? This video is unlisted, and I'm gonna show it to you guys. It was actually my first YouTube video. When I first started out, you know, I actually wasn't I actually wasn't a game developer. I was trying to teach Python. Let's go all the way back. Back to the simpler times. Back to when I had short hair. Okay. Okay, wait. Okay, we'll just... So yeah, this was actually one of my first videos. My name used to be Code the Universe. 3 years ago. Not that long. The intro was way too long. Just a laptop, guys. Just a laptop. I remember when I bought this monitor. This one right here. I was so freaking excited. I paid like $120 for this one. This one's curved. These two are like the same monitors. And then after like 2 years of having just one monitor, then I bought, you know, the second one. And then after a year, I bought the third one. And it's like, I'm not sure how necessary it is if you're not live streaming. Live streaming really makes you need more monitors, because here I have OBS. So this is like how I control, you know, where my cam is, everything. I can see the audio. I could pause, you know, I could pause alerts. I could control how my mic sounds. Read chat. Chat is right here. I have YouTube chat here. I have Twitch chat there. And then over here is where I do stuff off the stream, like I play the music, which I should turn the quality down here. Yeah, that's loading. Yeah, it's very necessary to have multiple monitors when you're streaming. Sup, Michael? Didn't know you were in Peaky Blinders, gang. Now you know. If your programming monitors equals life, having documentation on one screen, being able to read and type is another. Yeah. Monitors is kind of that one thing, like, once you have more, it's like, can't go back. I don't know, people who have the monitors up here, I'm not sure I like that. I'm content with 3. I don't need any more. This one could turn into a portrait monitor. It's on, you know, one of those things that I can rotate it and whatnot. Anyways, guys, we are going to do shader stuff today. I was looking at my New Year's resolution. For those of you who didn't see my last video, I just released a video yesterday. And I reminded myself that I had goals for this year. And one of those goals was to study shaders more. And although I did use shaders more this year, it's not really to my liking how much I've used it. I should have used it much more. So today we are going to take advantage of that. And I saw someone in a video using the visual shaders, and I've never even touched the visual shaders before. So where the frick is it? Okay, actually, I know where I could find it. I want to find my resolutions. Guys, I also ordered pizza, and the pizza's here. So I'll be right back. Be right back, guys. Pizza! Alright guys, we're not gonna eat pizza yet. Yeah, sorry. Today's kind of a mess. Yeah, I got pizza, yeah. I'm treating thyself. Whenever I release a video, I'm just like, yo. I treat myself, you know? That's what you gotta do. You dislike touching shaders? Someone steal her Super Nintendo logo for me, please. It's mine. See, pizza delivery. Is it in the apartment? Can't find me. I'm not hungry now, but I will be hungry. Today is Friday, guys. If you're not celebrating, you're not doing it right, you know? But yeah, guys, if it's too annoying to have that in the corner, It's weird. To have this. Just let me know and I'll close it. We cracking beers? Nah. I bought some Pepsi because I got extra wilds today. I don't drink soda anymore. Okay, guys. So, there was this video I saw that really made me think like, oh, yeah, this background I generated with Midjourney. That's why it's like, I just want this monitor to be private. Yeah, I think that's good. There, you guys can see more. Yeah, I want this monitor private, and I could also just do this. Bam! Okay, there, that's good. I like having one private monitor where I can look at feet. Yeah, this is, yeah, Midjourney. I did like, I don't remember the prompt, but, yeah. Brad, thank you so much for the follow. So I wanted to show you guys the video. Godot. Oh, okay, yeah. This one.
Hey everyone, a lot has happened since
I don't know if you guys have seen it. How many views does it have? 3.6. This one should definitely have more views. I'm gonna throw it to the chat. Really great streamer. So I am so glad she came to Godot. Thank you, Unity, for messing up. Thank you. She actually in this video she talks about porting her game from Unity. And here is for the YouTube peeps.
my last video.
And it's actually something that I need to do in Logcraft, which is when you get into water, show that you're in water. And I'm not going to do the same rippling effect that she does.
This is a result.
So look at this is, oh shoot. Let's bring the quality up. So this is,
anyway, despite that,
so look at this shader effect that she did.
Today I'd like to show you how I created this water trail effect, and also how I made the sprite gradually cut off as it goes into the water.
Looks, it's such a good effect.
Let's start with the water trail. Previously, I just had these particles, but I wanted to see if I could make something a bit nice.
Anyway, so I my point is not to do the trail, but to do the water, the part where it goes in the water, and she talks about it here.
So the other thing I wanted to show was how I made the sprite.
I have not seen the Game Awards, no.
Disappear into the water.
Water.
Although it might look slightly strange at times,
it looks awesome.
What's great about this method is that it can be applied to any creature. There's no need to painstakingly hand draw a different animation for each one, which
What's up,
I
Aspen?
really appreciate. Basically, if you move the sprite down and mask off the bottom at the same
Okay, so you mask off the
time,
bottom.
it kind of gives the illusion that it's in the water. In Godot 4, creating a mask like this is really simple. Sprite 2D nodes have the option to clip all children, which is exactly what we need. So in Photoshop, I drew up these mask shapes, making them slightly different depending on the creature's imaginary contour lines. I made sure to put a band of semi-transparency to help soften
Transparent?
the line. This is what it looks like in-game.
I don't understand.
Next, we want the sprite
Oh, okay, so this is just white, and then, oh,
to
okay,
move
got
up and
it.
down automatically while the mask stays stationary.
Okay, let's try to do that. Let's try to do it. I had to redo my thumbnail. Let's do something. Let's do something small. We'll do 500 by 500. Actually, it's pixel art. Let's just do 100 by 100. Awesome, Agathos. I'm really happy you need to have the problem so more people focus on Godot, make it popular. Hell yeah. Did you guys hear about the win from W4? So W4 has it's a company, and when W4 gets money, it doesn't necessarily mean Godot gets money, but they're, you know, the founders of Godot have started that company, and it helps, you know, the ecosystem. I guess they do many things and are paid for it, like porting Godot to different systems, I think. Not 1.5, 15. So they raised $15 million. So that's pretty awesome. And Groud works at W4. So what is the primary, yeah, I have questions. So what is the primary work you guys do? Because from my knowledge, I feel you guys, you do work around the Godot ecosystem. So like helping, like you get paid to port games to consoles and whatnot. Is there other stuff that you guys do at W4? Porting to consoles, cloud infrastructure for multiplayer. The money's mainly for that. Okay, cool. There was also, what was that company that was like the cloud infrastructure? It was like they gave a talk at GodotCon about like a Roblox Godot. It started with the W. Oh, actually, it's here. God damn it. The mirror. It was the mirror. That's not a part of W4. I taped the bottom here and it just came apart. Prehensile Tails. No, I think the mirror is a separate company. I'm not sure if it's a part of W4. Bee's knees. So yeah, and they've given donations to the Godot engine, so it's awesome. And plus, you know, when they have the manpower, I'll probably turn to y'all when I want to port Lawcraft. Hell yeah. God damn it, Dottle, you want. Okay, alrighty guys, you're gonna see standing up from third person. Oh, the monitor shut off. Oh my god, it's broken now. It's worse. She has risen. Not my mouse. I like change. Okay, should be good. W4 donates money and manpower to Godot, but most of the investment will be to support our products, of course. We need to be profitable. Yeah, of course. Yeah. That makes a lot of sense. But yeah, this is great for the ecosystem. So, good news. Alrighty, guys. Thank you, Groud, for the answer. It's so good lacking the export options. Unity is kind of one of the last negatives for Godot. With W4 all the... Whoa, but can't... Wait. Can't W4... Oh, no. No, that would get really messy if, like, Godot hired W4 to program something, right? That would get things messy. Because, like, one thing that Godot desperately needs is the asset shop. And I remember Emmy in GodotCon saying how it's difficult with like the legislative side of that. Yeah. One thing I would love to see with Godot in particular, but in open source software, is having bounties. So like particular bugs or features, you can put like, oh, by the foundation. Yeah, see, that makes sense. So if there's like a bug and I really need it fixed for my game, I wish there was a bounty system. I could say, bro, if anybody fixed this, I'll pay you $20. I know, like, I'll pay you $100. How does default do it? I don't know what that is. that way less asset flips. I mean, asset flips are inevitable, I feel. Yeah. Like, even the asset god Kenny, it happens to him, but I think he's still... I wouldn't even doubt it if people flipped the few assets I've made. But I don't think that's, like, a reason for deter. It's like saying, oh, let's not make a game because people are gonna pirate it, you know? It's like, it's an unfortunate, you know, thing, and it's... Yeah. Anywho. Why is it blurry? Okay, I guess I don't need it. So we're gonna do... I know I'm probably doing this a very wrong way. I'm gonna do Control-Shift-I for invert. And we're gonna get the eraser. And now it's gonna erase everything except for that. What's up, Snoways? How's it going? Whoops, I erased the background. Cool. Let's just... Okay, actually, let's make this smaller. Can't you just not... I'm not sure I'm doing it right. I know, Felipe, it's not... I thought people would enjoy seeing me from this angle, but everybody's telling me it's not safe. Guys, I know what I'm doing. Bug bounties will likely not happen. There's no way to ensure something that... True. Oh, that makes sense. Yeah, that makes it very tricky for sure.
So
okay. All right. Let's try to do this. I'm not good. I've used Photoshop quite a bit, but I'm not good at it. I'm not good at it. Okay, oh god. I'm supposed to do that. Good. There. There we go. And then the other layer needs to be semi-transparent. Can you just stop? Just stop. I don't want to rotate it. Just stop. Okay. That's just Chet telling on themselves. Guys, can you see that I'm like massaging my back? No, you can't see me massaging my back. You can kind of... I should have used A Sprite. That would have made my life actually much easier. Okay, whatever. Actually, let's just do it like this. Good. Guys, you can fail to success. Just that's what I remind myself every day. We're gonna fail to success. There. That's nice. Export. That sounds hard, doctor. I like that hat. I got it in Colombia. My bad, Doddle. And actually, Ollie chewed it up. I don't know if you guys can see. Here, she chewed it. Yeah. It has memories, guys. Okay. We're just gonna have shaders. Water thing. What is PS? Oh, Photoshop? I use it. I use Photoshop all the time. Okay, I use it when I have to do thumbnails, mostly. Yes. And I'm standing. Sub Mr. Evil Rex. Thanks, next gen. Next generation. Yeah. So, look, in cam number 1, I'm sweet. In cam number 2, I get a little unhinged in cam number 2. Okay, where? Let's change type to a sprite. And we are going to put Dr. Jackie and Mrs. Hyde. I like the sound of that. Are you guys ready for this? This is gonna look horrible. Okay, so we did clip children. Okay. So now, when we go down. Oh my god, that's so cool. I'm in the water. In the water. Listen. Listen, Russell. You're gonna tell me the answers. You're gonna tell. No, I don't wanna. Listen, Russell. What did you do with them? I don't know what you... Russell, I'm gonna tell you one more time. Okay. What did you do with... I ate the cookies. You see, Russell? You know? This isn't waterboarding. This is clip masking. That's pretty cool, though. That's pretty cool. Yeah, waterboarding, isn't that when you put like a, you know, I just wanted to know who ate the cookies, you know. Okay, so that's really interesting. So now how we're gonna do it. Okay. I hope. No, that shouldn't. Okay, so what we're gonna do. We need to put some custom data. Someone, I don't know if you're still here. Someone was asking about this custom data. Data. We're gonna do it right now. So, we're gonna have water levels. And it's gonna be an integer. Violet, thank you for the sub. Okay, so we're gonna come here shies. This might. Oh, damn. Oh, doom. Is that Violet? Isn't Manifesto just a to-do list, but in long form? She already has a to-do list. Karl Marx ruined that word, I guess. They have a bad rep? Why? Okay. Actually, should we? Yeah, we should. Where's my water? Where am I drawing water? Is there even water? I'm not even sure if that's... I think I trolled you guys, and I think there's no water. Look. There's never been water. You were fooled. I'm gonna make the seas run red. There wasn't water, it was just the background. This is when Russell starts eating the wrong mushrooms. This is what's gonna happen to the water. And then this music is gonna play. Okay. Alrighty, guys. Chill, guys, chill. So we need to make our own water. Schmelvin, thank you for the follow. Cool. You know, you could press F and it just fills it in. We're gonna want something more gradual. Gradually lighter. Wait, it should be getting gradually darker, whatever. I've been doing Godot shaders for a year. Awesome. Ah! Do you have Twitch chat open on one of your screens? Here is where I'm reading your message. And YouTube is here. Twitch and YouTube. $50 shades of water. You got your red chat, Snowies. Alrighty, guys. So, here's what we're gonna do. I haven't seen that movie. Should I watch it? Where's my 50 Shades of Water? Oh, I saved it as an Ace Sprite. I want my 50 Shades of Water. Shaders are like an old arcane magic to me. Yeah, same. Same. Yes, I had chocolate milk. Okay, good. I thought I overwrote something. Okay, cool. So now we'll use the custom data layer. So this one will be the shallowest. The most shallow. Okay. Cool. This will be 1. This will be 2. Can you just... No, this is 2. Oh, because I'm painting it. It's a little slow at the moment. Two. I'm working on my game Lawcraft. This one is 3. Shader demos. It shows, it's a plugin, it shows all my to-dos. Okay, we'll leave it at that. It's kind of slow when I'm updating the tile maps. So, we'll test a small section. Maybe like here. So this will be shallow. Cool. This will be a little deeper. Cool. And then we'll do the deepest in here. Well, for this little section. Yeah. Dope. Okay, let's take our main character. Dope. Oh shoot, I did it on the wrong layer. I'm an idiot. Wait, did I do it? No, I didn't. Good. I didn't. Okay, cool. And also, let's just do that so it doesn't look like shite under it. You'll be able to swim up to a certain point. Why does it look like that? Oh, well, I know what I could do. No. Oh, okay, I know what's happening. But it's all good. What I could do... I need to change that. I do have an itch, yeah. Here's my itch. Okay, I need to take my hat off. It's making my headphones tight. Oh, okay, cool. So now we need to get the character to detect. Okay, cool. Water, we'll call this water mask. Cool. And when we're walking, let's go to our state machine for movement. That it's good to cool-headed. What? Don't understand. Yeah, I know a little bit of Polish. How long have I been standing? Because I don't want to stand anymore. I don't want to stand. Where is that? Where's that information about how long I've been standing? I don't know where that is. Yucks. Oh, maybe here, actually. 14 minutes? Feels like forever. Wait. Okay, whatever. I really can't see where oh, maybe here in the... No, in the reward. Oh, it's been 25 minutes. Perfect. Great. Yeah, it's a piano. It's okay, Rex. I don't trust you anyways. Oh, no, I need to fix this. Make the chat fight it out. Alrighty, cool. Okay, so only when I'm walking. No, I don't want to do it here. If var, we'll date var tile position equals tile map get, it's local to map global position. If, and we'll say var tile map get cell tile data layer 0. It's from layer water. Oh, now you guys can see me type. Then emotional damage. Coordinates, tile position. Yes, and then we'll say if, so this is actually tile data. So we could say type tile data. If tile data var water level. This is the custom data we just put in. Should be an int. Tile data. Get custom data. I think it's just water level. Just make sure. Oh, you guys are so nice. Stop. Water levels. Just water level. Oh, stop guys. So this is the water level. Let's just, for now, we'll print the water level. See if it works. Gotta keep that ego in check or else you're gonna get a little beck. Okay, water level 0. Zero? Shouldn't say 0, honestly. 2. 0. 1. 2. 1. 0. 1. 0. Okay, that's strange. Okay, we need to look at that. I am Colombian. Yes. What's up, Coder Hog? Okay, for now, let's just erase this so there's no confusion. Oh, maybe I accidentally painted the out. Okay, just save. I remember in Unity when I used the paint bucket tool and it accidentally like painted the, it like had the whole world and my Unity kept exploding. Level 1? Okay, no, it's not printing anything. Now it's printing 1. Now it's printing 2. It's printing 2, 1. Now it's printing nothing. Okay. Let's try. It's 1. That is 1. That's strange. I used C++ in uni, but not since then. I do have the outputs to prove it. That is true, yeah. Yeah, Python is super similar to GDScript. Very. And yeah, you could use C#. C#. Okay. Let's put now the player. Let's just see what happens. So we'll say the of a function water level to position. It'll take the water level, which is an int. We'll do match water level. And we'll say if the water level is 0, we'll do this. 1, this. 2. This. 3. This. Well, actually, no. Well, we'll put 0 if there's nothing. Okay, so this is basically, we're going to put the position of the mask. So -1, -9 is the default position. Vector to I. -1, -9. Cool. Level 1, it'll be like this. Oh. Actually 0, 0. 0, 0 is default. Level 1 would be like this. 1, -3. Nice, real stuff. Didn't know that. 1 negative 3. Wait, was it negative? Oh, okay, whatever. We're doing the wrong one, but it doesn't matter. 1 negative 3. God. What? Why isn't this moving? Oh, that's the offset. Jesus Christ. I was wondering why it was negative 3. That didn't sound right. And let's give him a proper walk down. Why can't I change that? We'll just do idle down. Okay, cool. This water mask needs to move down. Thank you, Luke. I appreciate that. Have you used Game Maker? If you would, what would you say about Game Maker? I have never used Game Maker. Okay. Be here, so 2-0 actually is the default. Could pause that. 2-0. Just quick survey: is it better to start with the script for a presentation or begin with analyze and visualize? I have no idea what you're talking about, next gen. Three, 5. Three, 5. What are you presenting? Three, 7. Three, 12. Cool. Back. And that's how much we're gonna offset this sprite to 2D. So we don't need this actually. This. Bar, turn, offset. Okay, let's see what happens. It should work. I'm using a Microsoft ergonomic keyboard. I could change the... Yeah, I think it would be better to change the offset actually. Whatever, for now, let's just change the position. I could polish it up before, after. See if this works. so clunky. It's so clunky. It's not working even fully. Swimming in the pool, swimming in the pool. We are swimming in the pool. The spiders can't get us, the spiders can't get us. They can't swim in the pool. Nice. Yeah, I know. I know there's ways of getting this a lot more satisfying. Sound like some kittens. No, it shouldn't, because you're going ah with the tool. See, you're going ah, ah. Oh no, it's gonna get wet. Don't get my sword wet. Oh yeah, Mike. Oh, I'm gonna do that. Okay, this is just, you know. But guys, this is not the purpose. By the way, Twitch did not let me change the title of this. Let me see if I'm able to change it now. Oh, okay, now I can change the Twitch title. Before this stream, it literally did not let me change the title. So guys, we need to do some Godot shader stuff. But first, I need to post this short. One second. I just need to make it public. Don't worry. There we go. Alrighty, it's public. The spider sprites are just a replacement for people with allurophobia. What? Allurophobia? Allurophobia? Yeah, Raymond doesn't have arms. Pfft. Okay, I don't know if you guys know about this resource. But there is a book. And it's a beautiful book. The Book of Shaders. So I feel like this is a great place to start our journey. Look at this. Look at this. What is a shader? Alright guys, I'm glad that you guys can fully appreciate when I'm like this. Yeah, baby. We programmers out in here and we chillin'. Yeah, baby. Alrighty, guys. The Book of Shaders. What is a fragment shader? Does it really start on that? Okay. Max and relax. And guys, it's Friday. You gotta chill. Chill out, guys. Recline mode engage. Guys, programming push-up. Look, I'm not relaxing. 1. I'm doing sit-ups. 2, 3. Oh yeah, I feel the burn. 4. Oh yeah. 5, 6. We need to do 10. 7. Oh yeah. 8, 9. Oh god. 10. Oh. Oh yeah. Oh god. Alrighty. We did our physical activity for the day. We're good. We're good, guys. All right, back to the book. Okay. What is a fragment shader? In the previous chapter... What previous chapter? I feel like we're missing something. Okay, let's read the introductions. You know, sometimes when I'm reading a book and there's an introduction and it's very long, I don't get through the introduction, then I never read the book. I'm sure people can. That's always like an internal conflict when I'm starting a book. Like, do I read the introduction or not? Oh, that's a good idea, Snooies. This is not tea, this is water. Okay. The images above were made in different ways. 1 second. The first one was made by Van Gogh's hand, applying layer over a layer of paint. It took him hours. The second was produced in seconds by a combination of 4 matrices and pixels, one for cyan, one for magenta, and one for yellow, and one for black. The key difference is that the second image is produced in a non-serial way. That means not step by step, but all at the same time. This book is about a revolutionary computational technique, fragment shaders, that is taking digitally generated images to the next level. You can think of its equivalent to the Gutenberg press for graphics. Fragment shaders give you total control over the pixels rendered on the screen and at a super fast speed. This is why they're used in all sorts of cases, from video filters on cell phones to incredible 3D video games. What game is that? Journey? Oh yeah, I've heard of Journey. I usually read the intro after when I've confirmed I enjoyed it enough to go back and squeeze out the last drop of info story. That's a very good advice, Cody. Who is this book for? This book is written for creative coders, game developers, and engineers who have coding experience, a basic knowledge of linear algebra and trigonometry, and who take their work to an exciting new level of graphical quality. If you want to learn how to code, I highly recommend you start with processing and come back later when you feel comfortable. Yeah, processing is an awesome game. The Code Train, Daniel Schiffman, he's a big proponent of processing. Yeah. This book will teach you how to use and integrate shaders into your projects, improving their performance and graphical quality because GLSL, OpenGL shading language, shaders compile and run on a variety of platforms. You'll be able to apply what you learn here to an environment that uses OpenGL, OpenGL ES, or WebGL. In other words, you'll be able to apply and use your knowledge with processing sketches, open frameworks, applications, Cinder, interactive installations, 3JS website, and iOS Android. They need to add Godot here. Non-serial doesn't know why kids love the taste of Cinnamon Toast Crunch. I'm torn between GM and Godot for starting my project. I'm newer and I have a little bit of experience with GM, but Godot looks good. You're at a Godot stream. So I don't want to be biased, but do Godot. I feel like Godot is really the future, Spadusky. And at the end of the day, I think you'll feel much better knowing that you own the game that you make. And it's made open source. Like, it's made by open source software. And it's just an extremely... It's a place that's exploding at the moment. So it's only going to get better from here. Have you heard of Ezra? Oh, love him. Yeah. Yeah. He's actually been very supportive of me. And he started streaming. There are interactive examples for you to play with in every chapter. When you change the code, you will see the changes immediately. The concepts can be extracted and confusing, so the interactive examples are essential for helping you to learn the material. The faster you put the concepts into motion, the easier the learning process will be. What this book doesn't cover, it's not an OpenGL book or WebGL book. OpenGL, WebGL is a bigger subject than GLSL or Fragment shaders. To learn more about OpenGL, WebGL, I recommend taking a look at OpenGL. Okay, this is not a math book. Although we will cover a number of algorithms and techniques that rely on understanding of algebra and trigonometry, we will not explain them in detail. For questions regarding the math, I recommend keeping one of the following books in the third mathematics. Mathematics for 3D game programming and computer graphics. That looks like an interesting book. Okay, cool. Oh yeah, I have this dark mode. I don't. Thank you for reminding me. Never use Game Maker. I have a physics and I have a geometry book. Yeah, that counts. That's math. Okay, guys, let's do something very simple. Let's make a visual. I've done like shaders in Godot, but I've never done a visual shader. Godot intro to visual shaders. This guy I actually just found, and I love. He has such good content. I haven't seen a full video, but his videos are so cute. I will send it in the chat. There we are. Let's check this video. Oh my god, it's an hour. Okay, let's see.
Tool that can be used to create interesting effects for your game. Unfortunately, they're also a bit intimidating to get into. So, we're going to learn the basics of how shaders work, and we're going to explore how you can create your own shaders in Godot. This is a beginner to intermediate level tutorial.
That's good.
You should know how to use the Godot editor.
Okay, this sounds like someone I need to speed up, which is all good.
And you should know at least the basics of either GDScript or C#, as this will help you a lot when learning the shader programming language. We'll also use visual shaders, so if you don't know a programming language yet, you should still be able to follow along. We'll also need to use quite a bit of math, so it will be simple and run on your graphics card rather than on your CPU. They can change how meshes and textures are getting rendered. Everything that you can see in Godot is actually a mesh. Even 2D stuff like a sprite or text is still a mesh under the hood. Right here, we have some sprite 2D, a label with text, and a polygon 2D. And I've created a second scene where I added a wireframe shader to these, so we can see the mesh that is used to render them. A mesh has vertices and triangles. The vertices are these points that make up the mesh. The triangles are made by connecting the vertices. Now, in order to render a mesh, the graphics card will need to do a bit of work, and part of this work is to run a series of shaders. We start with the mesh, which defines the geometry of the thing that we want to render. Here, we just have a simple sprite. Now the graphics card will run the first shader, which is...
I'm learning Godot shaders.
the vertex shader.
Shaders in general.
This shader will run for each vertex of the mesh, and it allows us to modify the vertex data. For example, we can change the position of the vertex. Here, the vertex shader is moving vertices of the sprite to give it a swing motion. It's important to note that the vertex shader can only modify the vertex data. It cannot add or remove vertices or triangles. After our vertex shader has run, the graphics card now knows how the mesh is finally going to look. And the next step is to rasterize the mesh. Rasterization surely sounds a bit intimidating, so let's have a look at what it actually means.
Oh my god, we're gonna be able to move the grass when you walk in it. Yeah.
Rasterization means that we put a grid on our image and then look at what is inside of every grid cell. This is very similar to taking a picture with your smartphone camera.
Okay.
Here, we have a real-life cat holding very still so we can take a nice photo of it. Thanks, buddy. So, let's point our smartphone
My cat would literally say, I hate you, and then run away.
camera at the cat.
What's up, Patrick?
The camera has a sensor, and the sensor has a grid of sensor cells. Now each sensor cell will measure the amount of light that hits it, and will then produce a packet of data that we call a pixel. These pixels will make up our final image. Now, the graphics card will do a similar thing with our mesh. Here, we have the mesh as it is after the vertex shading is done. And we have our output window, where we want to render the mesh into. Now the graphics card will use the same technique as our camera, but instead of using the grid of sensor cells, it will use the pixels in the output window as a grid. And for each pixel of the output window, it will produce a packet of data that we call a fragment. It's not called a pixel because it contains a lot more information than just the color of the mesh. For example, the screen location of the pixel, information about the lighting,
UV coordinates, yeah.
UV coordinates, and more. So after rasterization is done, we got a bunch of fragments. And now the graphics card will run a fragment shader for each of these fragments.
Okay.
And with this fragment shader, we can modify the fragment data that the graphics card just collected when it rasterized the mesh. For example,
So this is the shader
we
pipeline.
can change the color of the fragment or its transparency. Once all the fragments have been processed, the graphics card will use the final information from these processed fragments to draw the actual pixels into our output window. This is all a bit simplified, but it should be enough to understand how the shader pipeline works in general. There are actually a few more other kinds of shaders that Godot uses, but for this video, we'll stick to vertex and fragment shaders. We'll also stay in 2D to keep the math as simple as
Thank you.
possible.
Awesome. Vertex shaders. Let's
Okay,
go.
So let's first have a look at the vertex shaders. I have a patch of grass here,
I do not know that, Bogdan. Sorry.
and I want to make it wave in the wind like we just saw when we looked at the shader pipe. This is something I cannot really do with the transform settings. Well, I could try to rotate it a bit, but
Spadooski, damn! Thank you for the sub.
that looks odd. I could move it left and right, but that also looks odd. And
Yeah, Patrick, I just found this dude and he is awesome. I will send you. And he has some other videos and it's really, really good. Such high quality videos. Look. He talks about Godot components, UI basics, node paths, state machines. And yeah, he released a month ago this video
skew setting,
about shaders.
well, it looks
Oh, Spadooski gifted. Oh, wow. Thank you,
somewhat
Spadooski.
right, but it moves the bottom
Congrats.
part of the grass, and I only want to move the top part of the grass. So I would need to modify the mesh of the sprite, which sounds exactly like the thing vertex shaders do. So let's create a shader then. We right click here, we select new.
Okay. Let's just do it. Okay, let's do it in Logcraft, sure. I was gonna open a new project, but let's let's just use our grass and no problem. No problem. Okay, so let's just do let's close all. Let's see how he has it. He has okay, just a 2D scene, sprite, and alright, cool. Let's close out of that, close out of that.
Resource, and then we search for shader. And we have two options, a visual shader and a shader.
Please use the
which is
visual
a shader in
shader.
the Godot shader language. We're going to start with the visual shader.
Awesome, because I've never used it before. Love this guy. Way too many tutorials are like 3 minutes long and go too fast for dummies like me. I get long. Isn't popular, but yeah, honestly, I do also prefer long tutorials. I feel you, Flex. Grass go swish swash. Grass go swish. Grass go swash. Okay, I think I have written a shader before. I don't know where I put it. See, that's for Dialogic. Oh, okay, scripts, shaders, cool. Alrighty, guys, we're gonna write our first visual shader. Let's go. Create. Was it a resource? So we do shader and then visual shader. Grass, go, swish.
For now, and let's name it grass.
Okay, yeah.
Now we want to assign this shader to
So there's two grasses. Let's do an atlas texture. And we'll come here, we'll go to the environment, vegetation, region, and we'll get our grass. Bam. Mario, thanks so much for the follow. We need to do it perfect. There we go. Cool. I don't want to save it. Okay. Maybe I should save it. Let's just make a folder tests. First shader. Cool.
our grass sprite. And we can do this by going into the inspector, then
Godot nears.
on the material, we drag our shader directly onto this material slot. Now we
Okay. Let's put this there. Cool. Nice. Perfect. So we come here. Let's close that. We go to there. Material. here, and then we drag our visual shader. Grass go swish.
We can
Okay.
double click the shader and we can edit it. The first this material slot.
Our first visual shader. This is awesome.
Now we can double click the shader and we can edit it. The first thing that we need to do is to change the shader type up here to canvas item because we want a 2D shader. Canvas items are 2D shaders. And then in the editor, we see that by default we have the fragment shader part of our visual shader enabled, and we need to switch it to the vertex shader part.
Okay.
So what can we do here?
That book of shaders was talking about fragment shaders.
There's a single note here named output.
What was said at the beginning
That
happens.
expects some output of our vertex shader. So, okay, we know where the output goes, but where is the input? Well, the input is not added directly to the shader graph, so we need to add it manually. We can right-click anywhere in the shader graph, and then in this window that opens, we can add new nodes to the graph. We want to add an input node, so let's type input. It has a drop-down, and in this drop-down we can select what kind of input data we would like to have.
This is
Since
so
we want
cool.
to modify the position of the vertex, let's select vertex. The vertex position is a vector. A vector is basically a little package that contains a bunch of numbers. Well, this vertex position vector contains 2 numbers. You can see this by looking at the little icon here, which reads
I started using Godot around 2 years ago.
VC2, which means vector 2. So this is a vector that contains 2 numbers. Now we want to change this position so that the vertex moves. So maybe let's add another vector to the position and see what happens, right? So right-click, search for add, and then we pick the add node, which has the VC2 icon, because we want to add 2 vector 2s. So now we can add something to our vertex position.
Which one? Oh, VC2. Okay, got it.
Because we want to add 2 vector 2s. So now we can add something to our vertex position. To do this, we first drag the position into the A slot of the add node, and then we can type some numbers here into the B slot. Let's maybe say 50 to X and 25 to Y. Well, it doesn't seem to be happening a lot, but this is because we need to connect the output of our add node to the output node. So let's do this. And now we can see that the whole sprite has moved to the right and down. So we know the coordinates and vertex shaders work very much the same as everywhere else. Let's save our shader now, because the visual shader editor likes to crash every now and then, so it's a really good idea to save often. We were able to change the vertex position, but why did all vertices move? Well, the graphics card will call this shader program for each vertex automatically. But, and this is really
I think mine offsetted more than his because of pixel art.
important, we have no control over the order in which this is done. It will happen in parallel for all of the vertices. And this way the graphics card can use its hundreds or thousands of shader processor cores to do this as fast as possible. And this is also the reason why we cannot add or remove vertices in the vertex shader, because we only get called to modify an existing vertex.
Selecting vertices.
Okay, now we are able to move the whole sprite by moving all vertices, but we only want to move these upper 2 vertices here. So how can we find out which vertex we are currently working on? Well, we can use the vertex coordinates to find out. So let's have a look at the sprite, and then let's see what coordinates are we actually getting here. The vertex coordinates are given in so-called local space, which means that they are relative to the sprite's center and they are in pixels. So our sprite is 256 times 256 pixels, and the center would then be at 128 pixels to the right and down from
So ours is 16 by 16.
the top left corner. And this center gets the coordinates of 0.0, and then everything else is relative to this center. So when we know this, we can calculate the coordinates of all the 4 vertices relative to the center. And if we look at these coordinates, we can see that the upper vertices have something in common. Their y-coordinate is negative, while the y-coordinate of the lower vertices is positive. And we can use this to find out whether the vertex that we are currently working on is one of the upper vertices. Now, which node would we use for that? There is an if node that allows us to compare numbers, so maybe let's add one of these. So we right-click, we search for if, and we add it. So now the if node has 2 numbers, a and b. And the if node will return a vector 3 depending on whether a is equal to b, greater than b, or smaller than b. For each of these cases, we can configure what the output of the if node should be. So let's first plug the y-coordinate of the vertex into the a input, because we want to know if this is negative or positive. But how do we only get the y-coordinate of the position? Because we only have a vector 2 here. Well, we can click this little triangle here to get additional outputs that split this vector 2 into its components. They are somewhat confusingly named red and green, and this is because of some special convention in the shader language that allows us to use different names for the components of each vector. So x can also be named red, and y can also be named green, and z can also be named blue, and so on. But It's just different names for the same component, and we will see this later when we work with the shader language. So for now, we just need to know X is red and Y is green. So we get the green output, which is the Y coordinate, and put this into our if node on the A input. The B input we keep at 0, because we want to compare the Y input with 0, and then we can set the output for A is less than B to be some value that we want to add to our vertex position, maybe 100.0.0. So
They're
our
also
if node will now
same,
return vector 3
doctor.
with 100.0.0 if the Y coordinate of our vertex is less than 0, and it will return 0.0.0 in any other case. Okay, so we can now plug this into the add node.
Wait,
And
what?
in any other case, coordinate of our vertex is less than 0. And it will return 0.0.0 in any other case. Okay, so we can now plug this into the add node. And we can see that only the upper vertices are moved, while the lower vertices stayed in place. When we look at the shader graph again, there's one odd thing. The add node expects a vector 2, but we plugged in a vector 3. So what happens with the third component?
There we go.
Well, in visual shaders, the editor will automatically convert between different vector sizes. In our case, we need a vector 2, but we got a vector 3 from our if node here, so the editor will just drop the last component. And if it's the other way around, then the editor will simply add a 0.
Cool. So like, yeah, we could do this logic like, whoops. Just when you know, walk in the grass, it does this. Bam. It does that. And it gives that really nice, effect.
When we look at the shader language later, we will have to do these conversions ourselves. So we were able to...
Do you, can you do everything in visual shaders? Like, do you even need the shader language? I don't know why I've never taken a look at them. Like, the shader language has always thrown me off. And then, at the end of the day, this is just being converted, to the language. Whoa. Wait, do I have that? I don't.
Move only the upper vertices.
So look at them,
we'd like
doctor.
these vertices to sway back and forth. So we need to add some animation to our shader.
Ooh, animation. Yeah, animating with time. Let's
If we want
go.
to animate the swaying of the grass, we need to somehow change the value by which we move these upper two vertices. If we set the x value to -100, well, then we can see that the grass sways to the left. And if we set it to 100, then the grass sways to the right. So we need to change this value from -100 to 100 and back. In GDScript
Let's
or
go,
C#,
Mr. Evil
we have
Rex.
the delta time variable that
See, guys, it's all about who your friends are. If you guys are my friends, you'll learn something.
we could use to calculate values that change over time. So let's look in the list of nodes if we can find something similar. So right-click, and we search for time. And here we have a time node, but the description isn't really telling us what is actually in this time variable. Is it the delta time since the last frame, or is it something else? So let's have a look at the documentation. Switch over to the browser. And here it reads global time since the engine has started in seconds. Always positive. So how could we use this to animate our grass? In a normal script, we could use some
You could do pretty much anything in visual shaders, but due to it being more high level nodes, sometimes you have to write expression nodes, which is different. Okay, good to know.
variable to store the current value
Okay.
and then maybe add some delta to this variable each frame. But in shaders, we cannot store variables between frames. Everything that we calculate is lost when the shader is done. So everything needs to be calculated from scratch each time the shader is run. For now, let's try to use this time variable to get a feel for how it works. And let's say we want to move the upper vertices by the amount of time that has passed.
Oh, so we
For
move
this,
this.
we need to get the time into the x component of this vector.
Oh,
But
God.
unfortunately, we don't have a little triangle here, like we have for the input node. So we somehow need to build a vector 3 from components. And there's a node for this, which is called vector3 compose. So we right-click, and we search for vector3 compose, and there it is. And we add it.
Vector 3.
So this has 3 inputs for x, y, and z coordinates, and it will return a new vector 3. So we plug the time into our x component, and then we plug this new vector 3 into our if node. Now the grass has moved, but it seems to stand still. Maybe let's zoom
It's
in a bit,
moving.
and we can see that the grass is
Ours
actually
is
very
pixel.
slowly moving. So we get
Ours
some
is
on
better.
animation, but we still need to find out a way to make this grass sway back and forth. And also, it should move a bit faster. So
It
we
should
need a
move.
mathematical function that takes a number and then returns a number that goes back and forth based on this time input. And one such function is the sine function. Let's have a look at how this function works. So let's move over here into the browser.
Sine
And we can see this is a
function.
plot of the sine function. On the x-axis, we have the number that we put into the function. And on the y-axis, we have the number that we get out. So when we put the number 0 into the function, well, then the function will output a 0. And if we increase this number, I'm dragging this here to increase, then the function will return larger and
Math time.
larger numbers until some point where the output gets smaller again.
Guys.
And eventually it gets
I'm
negative
so sorry.
and then returns back to 0. And this repeats forever as we put in larger and larger numbers.
You know what's the only thing I remember from trigonometry? Sine starts at 0, cosine starts at 1. That's all I remember.
So if we put the time into this sine function, we should get a swaying back and forth motion. Let's go back to Godot. So we right click and we search for sine.
The thing is, you don't use this a lot in your everyday life. I mean, in game dev, you kind of just a
Okay,
little
now
bit. Oh, float function. Oh, what? Okay. Sokotoa. Sokotoa. Everybody wants to suck a toe. I'm sorry. I don't have a foot fetish. Do you? Raise your hand if you... I'm sorry, guys.
Put the output of the time into the sine node and the sine node into the x component of our vector 3. And if we zoom in very closely, we can see that the grass is now swaying back and forth
Really?
by a very small amount. And this is because the sine function returns the value
Wait, did he put it in here?
of our vector 3.
Oh, sine. Yeah.
And if we zoom in very closely, we can see that the grass
My
is now
God.
swaying back and forth by a very small amount. And this is because the sine function returns the
Oh
value
my
between
God,
-1
that's
and
so
1. So we only
beautiful.
sway back and forth by a single pixel. This is obviously not enough. So we need to increase this range. And we can do this by simply multiplying the output of the sine function.
We don't
with
need
some
to.
number make it
Pixel
sway
art.
more pixels.
Am I right?
And we want to
High
sway
fives.
by 100 pixels left and right, so we multiply.
In terms of particles, for instance, this can get a bit worse because the library of available high-level nodes for visual shaders isn't that great. Makes sense. Makes sense, guys. Look. Windy day in Lawcraft. You know, you're just walking around. Oh my God, Frumies, get out of here. I don't think you really want to know who here has a foot fetish. Guys, on my third monitor, there's literally just one big foot. I prefer elbows. Anybody want to see my ankles? I think Jackie just accidentally revealed a secret. I felt a disturbance. I knew you would come out of your little cave like this. Who has a foot fetish? Chat. Oh my God, I forgot you guys can see me. Oh my God. Sorry, I didn't mean to summon all of chat like that.
This output by 100. So let's add a multiply node. Right click, search for multiply. And we need to check that the output of the sine function is a float. So we need to use this multiply with the float. So now we can plug the output of the sine function
I don't need to do that.
into
I have
this multiply
pixel
node,
art,
and then
dude.
we multiply by 100. And now
Oh
we're
shoot, okay, I wanted to get funky. I wanted to get funky like that. Let's do it. Float dope. Guys, by the way, I'm not at home. I'm in an office. They're literally playing an accordion. Welcome to Poland. I love it. I love it though. I love that. I wish you guys could hear the accordion playing in the background. You can hear it? You're a liar. You're a liar, that liar. Okay. Multiply. Let's go. Let's go. Oh yeah. Oh yeah, baby. Let's go. Oh, I didn't mean to do that. It's windy in Lawcraft today. It's windy. Oh, damn. Look at that go. Look at that go. Oh my God. I really want to see what it'll look like when all... Can you apply... What's up, Element? Patrick. Okay, Patrick seems like the shader god at the moment. Patrick, can you apply shaders to individual tiles?
back and forth by 100 pixels. Well, that's great. But I think it's swinging a bit too fast, so I'd like to
It's
slow it down.
not too
How can we do
fast.
this? What we can do is we can
Ja mówi bardzo dużo po polsku. Nie widziałeś?
multiply the time with some number to make it faster or slower. So let's say we want to make the time go half as fast. We could multiply this with 0.5 or 1/2. So let's duplicate this multiply node here. Can press Ctrl D to duplicate.
Okay, wait, guys. Actually, I already know the answer to my question. Are you guys ready for all of Logcraft to get funky? Wait. No problem. I don't need to because actually these are tiles. Watch this, guys. Watch this. Watch this. Grass goes swish. Grass goes swish. Grass goes swish. Are you guys ready for the new and improved Logcraft? Are you guys ready for the new and improved Logcraft? Let's go. Oh, I don't want to scream now because they're playing the accordion and I respect that. Oh my god. Oh my god. The world. Okay, this is definitely what's going to happen when you take the wrong mushroom. This is so trippy. Oh, what happened to their... Oh my god, this is really insane, honestly. What happened to this? Yeah. Imagine you're at your accordion lesson, some lady screaming hi. Should this grass also get smaller when it swings? I mean, highest point in the grass, keep wide. Yeah, I mean, that's true, yeah. Guys, this is very also it's like, but one thing, like, we need to add some randomness because they can't all be oh my god, even when oh my god, even when the game is not played, it's still doing it. That's so scary. Hold my beer for shader. Okay, let's just finish. Yeah, don't worry, Ben. All of chat has been warning me.
And then let's plug the time into the A slot.
No, I'm not.
Multiply it with 0.5.
What is that doing?
And the output goes into the sine function. Well, that seems to work pretty well. So now let's try if this also works for speeding up the animation. So let's maybe multiply the time with 2. Oh, we change it here to 2. And it does. Okay. Well, this is way too fast, so let's move it back to 1.0. But now we can make our grass sway, and we can also control the speed of this animation, which is great.
Writing vertex shaders with... Oh, no,
so now
no,
we
no,
have
no.
a functioning visual shader. Let's see how we can write the same shader in Godot's shader programming language.
I don't want to. Should we do that, chat?
Our vertex shader experiment was quite successful, so let's have a look at the fragment shaders next. Fragment shaders allow us to change the fragments that the graphics card has produced when it rasterized the mesh. So we can change how things look before the graphics card will actually draw anything.
1 second, guys. I need to organize my windows.
As an example, we are going to make a shader that can replace a color. Such a shader is useful in a game where the player can select the color of their units. With the shader, you can just make one unit image and then replace the unit color on...
My issues with tutorials, sometimes they'll tell me to do, but they don't explain what's actually happening when the code does what it does. So it limits me reusing it in the future. I could see that being frustrated. I mean, you know, there's all different... There's even knowledge in that. Even if you don't understand something, it's good to use it. And then one day you'll dig deeper in understanding. You'll dig deeper and understand it. So accomplished that I learned something. Okay, let's move on to the next level. No! Alrighty, guys, 1 second. I need to go to the bathroom. I will be right back. Oh my god, now you guys are gonna see me leave. That's so weird. I don't like that. Okay, no. I don't want you to see me leave. Okay, I want to leave in peace. I want to leave and... Sorry, that was kind of a pun. I will be right back. I said leave in peace, but then yeah, it sounded like that. Alrighty, I just want to quickly see how my short is doing. I'm very new to shorts, and they're kind of confusing, and they're very different. 19 views, yeah. It's doing great. All right, guys. Yeah, it's sufficiently dead enough. I'm not that hungry right now. Okay.
On the fly in the game, so you don't have to make a lot of images with different color variations. I have prepared a sprite of a character, and now we want to replace the color of the shirt that this character is wearing. For this to work, the shirt needs to be in some color that is not used anywhere else in the image, so
Makes
only
sense.
the shirt's color gets replaced. And this is why the shirt has this nice green color. I have a second copy of this image here that we can use for
Is there anything else in Logcraft? Did you see a video of it? Yes, we were that's why we were doing that water stuff. Awesome video. Make some shorts from your funny clips, you nerd. People like to laugh. You have some funny. Thank you, Doddle. I appreciate that. Okay, anything that we can change the color? Could be these berries. Okay, let's see what he's getting on about.
Our shader. We will again start with the visual shader, so let's create one. We right click, select new resource, and then we search for visual shader, and we name it color replacement, and again we drag it onto the material slot of our sprite. And then we can double click it to open it up in the visual shader editor. Again, we need to make sure that the shader type here is set to canvas item because we are making a shader for 2D.
Mm-hmm.
This time, we stay in the fragment part of the shader.
Mm-hmm.
We can see.
Oh, let's just do it. Okay, let's do the berry bush. What if you want multiple shaders, though? Because there's only one shader. Oh, you could just put them in the same. So no. Let's do it here. You could just put extra little thingies here, I guess.
That the output is a bit different from what we saw in the vertex shader. The most important output is the color that the
How's it going with you, Sorota? Is it snowy over there?
We also have an output for alpha, which controls the transparency of the fragment. And there are a few other outputs, but we won't get into these for now. The input works
we
exactly
can't because this is a fragment shader. Okay, so we need to do a new one. Because there's fragment shaders and vertex shaders. I learned something new. Giant Robot Ninja, how's it going? Oh, so if we do lighting, I mean, we could do lighting with shaders, basically. I think if we really want to make Logcraft look sexy, we need to have like a lighting level on each tile. Because I feel like if we know, like that, Minecraft does that. Each face of the cube has a different lighting level. And I was, if you guys have Xbox Game Pass, you should definitely check out Sea of Stars. It's a beautiful pixel art game. And they actually have a documentary where they talk about the making of Sea of Stars. Sea of Stars documentary. And yeah, they said, here's the documentary, by the way. And they said that when they were first working on it, they were first figuring out how they were going to do the visual effects for it. I don't know where it says that. Good look.
And we decided, like, let's see how far.
Svet! How's it going?
Oh,
hi, Nick.
Knew that's what I wanted
This is the leader of the studio. But look how beautiful this game is.
Thierry gave me is what the
It's like when you look at the lighting, you're like, this is 3D. It's so
game became. Without spoiling too much, the idea of like the solar, the lunar.
It's a beautiful game. All right, let's go back to the shaders. So we need to make a fragment shader. Oh, here. So yeah, just thinking about the fact that you can control the one color, it made me think about lighting, and then that made me think about each tile having a light level. And that could easily be calculated because if you put a torch down, it can alter. There could be a transparent layer that has custom data information, and when you put down a light bulb, it can draw. Do you guys understand what I'm saying? Okay, let's... I need like a grid. 1 second. Let's get a grid. So, this is the tiles. We could have so there'll be a light level. So I guess that'll also take into account like the time of day. So if it's let's say if it's morning, the light would probably, you know, be at maximum level. So all the things will be 6. Maybe if there's like a tree, then like under it, it could be like 5, 5, 5, 5, 5. If it's the evening, then like the tiles could be, I don't know, 1. And then if it's nighttime, the tiles will be 0. And if you put a torch down, the torches, we could have like a tile map layer, which, you know, would hold this information. It could contain that, you know, those values around it. So like here, it could be 6, 6, 6, 6, 6, 6, 6. I'm trying to summon Satan. And then it gradually goes out 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. And basically, if this shader, you know, where we can change the color, this bush can detect, you know, what level the light is. And so if the bush, let's say the bush is here, it's on level 5, it can change the colors of it accordingly. And moreover, it can make it move. So it's like the flaying of the... That's pretty... Yeah, shaders basically open up a whole level of complexity, but beautiful. Beautiful complexity. All right, let's get back to the video. With a simple gradient. True. Phallic tree. Started to beat the coughing. Damn, yeah, Svet's been battling COVID. Yeah, of course. There's, you know, with game dev, there's like a bunch of ways of doing the same thing. Oh, so sorry, Sorota, I just read your message. It's dry. It's been snowing so much here.
In the vertex shader. So for getting an input, we need to add an input node. So
new shader. Do we just drag? Okay, we need to make that shader here. Scripts, shaders, create new resource shader. We're gonna do a visual shader. It's gonna be bush color. Mohaya, thanks so much for the follow. Bam. Bush color, we put it here. Click. The shader's here. We double click. Yeah. It's gonna be a fragment shader. Cool. All right. Let's finish with the video.
let's right click and search for input and edit. And we can see that we have quite a
Wait, how do you...
few in. So for getting an input, a few other output should get. The output is set to canvas item because we are making a shader.
I forgot to do that. Where's the canvas item?
for 2. Again, we need to make sure that
Okay, here. Yeah. Okay. Great. Yeah, that's when it
the
changes
shader
that.
type
Cool.
up here is set to canvas item because we are making a shader for 2D. This time, we stay in the fragment part of the shader. We can see that the output is a bit different from what we saw in the vertex shader. The most important output is the color that the fragment should get.
Yeah, guys, it gets dark at like 4:20. When is the winter? When is the shortest day of winter? I want that day to pass. It's so annoying. I hate that.
We also have an output for alpha, which controls the transparency of the fragment. And there are a few other outputs, but we won't get into these for now. The input works exactly like in the vertex shader. So for getting an input, we need to add an input node. So let's right click and search for input and edit.
Input.
And we can see that we have quite a few inputs. We want to select color to get the color that the graphics card assigned to the fragment when it rasterized the sprite. This is a vector 4, a vector with 4 components.
What country
The
are
first
you
3
in?
components are red, green, and blue. And the fourth component is
21st.
the
Oh
alpha
yeah, it's
channel, which controls the
21st.
transparency. We can also click this little triangle like we did in the vertex shader, so we can get access to each element of the vector. Color values in shaders are always given in a range between 0 and 1. And this is
Now I know why you're so grumpy.
different from how colors are usually represented in other areas, where red, green, and blue are given as a range between 0 and 255. For example, let's have a look at the color of the shirt of this character.
If it makes you feel good, Svet, I've literally been, since I was sick like 3 weeks ago, I still have like the remnants of a cough where I'm just like, I don't know, it's weird. I didn't have
We can use
COVID.
this to pick the color of the shirt. Now we can see that the shirt's color is 0 red,
How did he do that?
this to color of the shirt of this character. I have a little color picker here, and we can use
Oh,
this
okay.
to pick the color of the shirt. Now we can see that the shirt's color is 0 red, 255 green, and 0 blue.
Where did he get that color
In
picker?
the shader, we need to give these colors as a value between 0 and 1. So if we want to know how this color would be expressed in the shader, we can use the raw tab of our color picker. So let's open the color picker again, and then select raw.
Oh, he had it as like a node. It's 3 days before Christmas. This is why Christmas is on that day, the first day that is longer than the shortest. The first day that is longer than the shortest day of the year. Easy to remember. Nice. Good rule of thumb. Okay, so we want to color pick that.
And then we can pick. And the color picker will automatically convert the color that we pick to a range between 0 and 1. So now we can see that the shirt's color is 0 red, 1 green, and 0 blue. So how can we use this knowledge in our
Let's
shader?
get rebirth, guys.
Well, the shirt is the only part in this image where the green part of the color is 1. So we could try to use the if node again, that we already know from the vertex shader, to check if the green channel is 1, and then
Okay.
replace the input color with some other color. So let's try that. We right click, search for if, and then we edit. And then we plug the green into...
Yes. I'm a boxer. The pagans really knew what they were doing. If. Okay, let me try to do it. Oh, okay, I don't need.
Our
Oh, if green. Oh, well, we need to do. Okay, whatever.
Now we check if the green channel is exactly 1, so we put a 1 into the B slot. And then let's say
If green is.
when A equals B, we want to make the shirt blue. Blue would be 0, 0, 1. So we type 0, 0, 1 into the A equals B slot. And in all other cases, we just want to have the original color. So we plug the original color into the other 2 slots for A is greater than B and A is less than B. And now we can plug the output into our output node. Now everything is connected, but the shirt is still green. So what's going on here? Well, the problem is that we are comparing 2 float numbers here. And there's always some potential rounding
I
error
don't know
when
if
we
this is
compare 2
right.
floating point numbers and want to know if they are equal. This is the reason why this node has a tolerance setting.
I don't get it
When
either,
we
yeah.
increase this tolerance, then the node will still treat A and B as equal.
I just don't get this part. Oh, when A is equal. When green. Oh, okay, yeah. Okay, I get this part now. Okay, what part don't you get, Minesweeper?
Even if they are a tiny bit different. So let's try to set the tolerance to something small, maybe 0.001. And now,
Oh. That's cool.
shirt is actually turning blue. But we get this really ugly seam here where the shirt still remains green. So let's find out.
Not
why
us, because we have
I'm going to set
pixel
the
art.
filtering on the second sprite that we have here to nearest, so we can see the original pixels of the sprite without any interpolation.
Wait, what? Oh, nearest. Okay,
Now
we
let's
don't
inspect
need.
the
We already
colors of
have
the seam of
nearest.
this shirt. It looks like that they are actually in different shades of green. Some are a bit darker, so the pixels blend more nicely together with this black border. Let's verify this maybe with our color picker. So we can see that the red
It's
and blue parts
Pepsi.
of the colors at the seam
Because
are
you're
still
sexy.
0. But the green part falls below 1, where
I'm
the
sorry,
shirt color
guys.
is
I'm
blended
unhinged
into
on
this black border.
Fridays. Yes,
So
we get it.
maybe we could try to increase the tolerance setting.
Awesome. I think this was a good intro to shaders. Don't you think? I think this was a really nice intro. Why are you still doing that? I like the grass go swish. Okay, so it's like stored in some different type of memory. How'd you kiss? Awesome, Svet. You get that meta quest. Unhinged on Fridays? No, you're always unhinged for extra. Okay, guys. Because we're following the same thread of shaders, there's a really cool video I wanted to show you guys. I didn't watch the whole thing. Oh, wow. There's already Godot 4.2.1. That's awesome. Let's watch it. It is called... I coded a dynamic sky with planets in Godot. No sky shader. Oh, wow. This is not about shaders, actually. I'm going to get a slice of pizza. Finally, I'm getting pizza. Yes, we could change it to a blueberry bush. Ready, guys. Oh, I'm gonna get a plate. Because I'm not a savage, okay? I am not a savage. But yeah, this video is really awesome. Oh, Miss Silverback, you want it? That's the one we were watching before.
So over the past month since my last video, I started out making art for my game. But after about 2 weeks in Blender, I quickly got the strong urge to do something else that didn't involve 3D modeling for a while. So I chose to start working on my day/night system. As the title suggests, my sky doesn't make use of the sky shader, but rather every single piece of my sky is a 3D mesh. Mostly spheres. This allows me to build a really complex sky with a lot of moving and changing parts. Even the solid background color is controlled by a material on a huge inverted sphere.
Wow.
This is so I can easily control the rotation or tilt of the sky, useful for rotating the stars at night, and offsetting it based on how far north I want my game to take place. I'm not gonna go over the basics of how a dynamic sky works. Basically, if the sun is above the horizon, transition a bunch of materials and settings to their daytime values, otherwise set them to their night values. I do want to show you guys how I get this effect where
Do
the
you guys
planets
think
appear to
that-
be shaded and blend seamlessly into the sky.
Do you guys think that he's talking? It kind of sounds like an AI.
So objects in the sky have to be shadeless. We don't want them to be affected by the lighting. We also want the dark side to always match the sky color. So to do this I had to fake shading within the shader
Jesus.
of the planet. But how do we shade the night side of a planet if it isn't affected by lights? Well, luckily there's a simple
He's using a fragment shader, guys. We learned about that.
way, and this can be helpful for more than just planet shaders.
Why do you guys think that people do that? Do you think that they're like self-conscious about their voice?
Here I have the visual shader for my planets. On the vertex side I have a vector 3 parameter that I update every frame from a script.
Okay, so the input is a normal. Vector 3 parameter. Light direction. Okay, let's explain it again. Because we know about shaders now.
Visual shader for my planets. On the vertex side I have a vector 3 parameter that I update every frame from a script.
Okay.
I calculate
So
the local
basically you can rotate. Yeah. That's actually pretty cool. Oh, or crap microphone. That's true. Yeah, in 3D you can like rotate planets and everything.
localized
the
direction of the
meshes.
sun relative to the planet, then normalize it and pass it to the shader. So back in the shader I also get the normal, which is basically the direction that a given point on the sphere is pointing.
Makes sense.
Then I plug both of those values into the dot product node. If you're unfamiliar with the dot product, like me before this month to be honest, Godot has a pretty lengthy explanation in the docs. But I found it kind of funny that the Unity docs only has these 2 sentences, and this one is the only sentence I ever needed to read. If the 2 inputs perfectly match, then it outputs a value of 1. If they are polar opposites, then the output is -1. So we plug that result into the color output.
He fired some shots at the Godot docs.
Now back on the fragment side of
Godot docs had a lot of information, and Unity docs had just one good sentence where I understood it.
the shader we can get that color, and see what this is doing. I use it as a factor to blend between 2 colors. The day side color and the night side color. I use a curve to sharpen the day-night blend a bit, and that's it really.
Wow.
Then in code, whenever I change the color of my sky material, I also change the night side color of my planets to match
Thanks for
it.
the follow. Mel Noodle.
Notice what happens to the little planet whenever it goes around to the dark side of the gas giant.
Wow.
It just disappeared as if the big planet cast a shadow on it, even though they're both shadeless. Well, to create that effect I have another input parameter on my planet shader called eclipse. In code I take the direction of the sun and gas giant relative to the
True flop donkey. Okay, guys, I'm getting one last piece of pizza. What's up, Brandon? This is an FOSS thing. Been setting up OpenStack at work. The documentation.
little
But
planet
yeah, why does it say no sky shader? He's basically using
and compare
a shader.
them. If they are an almost match, then I know the little planet is probably in the shadow of the big planet, so I apply its eclipse factor overriding its entire surface with the night color. Finally, I do the exact same calculation to transition into solar eclipses as you'll see here.
That looks so cool. Oh my god. Oh.
Now it's nighttime in the middle of the day like I would expect you
Wow.
would experience on Europa or Titan. The transition would look much better with a flare effect on the sun, but I haven't gotten around to that yet.
That is so cool.
So this is a fantasy world if you couldn't tell, and it will have magic, and will be loosely based on mythology, which
I'll
is heavily
fold it.
influenced by astronomy. So the astronomy of this world is very important to its lore and even some gameplay. That's the plan right now anyway. So knowing what and where objects are in the sky will have its uses in this game. So I added this little feature that helps with that. For now it's hidden in this little basic menu I created. I also added some basic graphic settings so I can run the game on a potato. But this astronomy perk is what I wanted to show you. This may be a skill players can learn in the game someday, when I actually have a game to play. So now in the sky you can see the names of all the objects. I added the Big Dipper just as a placeholder constellation for now.
It's
Eventually
so cool.
I will design my own constellations. I will most definitely change the names of everything eventually as well.
This isn't a real person. This is an AI making a game.
I guess the only thing left to show off about my sky would be the meteor showers, but you've probably noticed them throughout this video. I increased their frequency as well as the speed of the sky for the sake of this video. Normally they would be more rare and the sky would move more slowly. One glaringly obvious thing this sky is missing is clouds, of course. But I plan to implement a weather system that will manage clouds, wind, temperature, rain, snow, seasonal changes and so on. So it will be a really big and complex system and I'll get around to working on it eventually, but right now I'm more interested in finally implementing some gameplay features, so in the coming weeks that's probably what I will focus on.
What's up, Omar?
As a final note, I would like to address how many views and subscribers I have gotten. Over the last month alone this channel has gotten over 7,000 views, which is insane to me. Also
Good.
kind of scary. I know there are some people who probably scoff at those numbers, but I've never had an audience greater than 20 people in my life up until now.
Aww.
So thanks a
cute.
lot for watching, liking, and or subscribing. As always, any feedback is appreciated, and
Let's
I'll
see
see
how many
you next
views this
time,
one-
hopefully.
This one only has 974 views? What? Guys, give that video a thumbs up. I thought it had like thousands of views. Wow. Oh, that was posted 4 days ago. Makes sense. Awesome. Simulations are crazy nowadays. I'm a Linux tech support for car manager. They run collision simulations on our clusters, comparing video renders to the actual crash tests. I don't really understand what that is. Okay. Let's watch another Godot shader. Godot shader devlog. Because I'm almost done with my pizza. Oh. I have created visual shader out of Godot 4. I made an endless ocean in Godot 4. This was 3 years ago. I made a palette pixel shader from scratch in Godot. A palette pixel shader? What does that mean?
I created this character to use in my indie RPG
What does that
game.
mean?
Let's call him Bob. Now, don't get me wrong,
Guys, that's my grandfather's name.
Bob looks nice as far as 64 by 64 pixels character sprite goes, but I think we can make him cooler. How, you might ask? Well, you probably can guess from the title. I want to customize his colors. So I set out to do just that. The immediate thought is to use a shader. After all, that's what shaders are for. Programs that run on the graphics
up,
card
Alexi?
and control how the pixels on the screen are rendered. Before we jump immediately to shaders, there's one more consideration we
Booty.
need to go over. If you are used to using Godot, you know there's a thing called modulate. Instead of deciding what the pixel's color should be, you can modulate the existing color to give it a sort of tint. But it comes with a bunch of headache that I don't
I do not know the Godot shader website.
want to get
Can
into.
you send it?
For example, if you want to target a very specific color value with this, you would have to figure out what modulation you need to arrive at the color. You can't simply pick the color and hope that it lands on it. So this is a no-go for me. Let's get back to the shader. Select the sprite node, scroll down to materials, create a material, create a shader, and write a few lines of code that basically says, if you see a specific color, replace that color with another. But hold on, this has a problem. Well, several problems actually, but I'm thinking about this one specific problem. Go ahead,
Alrighty, Patrick, take care.
pause and try to guess what it is. I'll wait.
I don't know
Got
what the
it?
problem is.
The main issue is this. What if different parts of the sprite also share the color?
Oh, that's the problem,
Then
yeah.
this shader would replace the parts that I didn't want. Sure, I can design the sprite so that colors do not
A
overlap,
mask,
but
maybe.
if the player changes the shirt color to match the hair, then try to change the color again, both the hair and the shirt now have the same color, so they would both change. The simplest solution-seeking part of our brain might say, hey, let's separate the sprite into multiple customizable portions so the shaders are applied separately. This might solve the issue, but still, what if I wanted to add more details? Please. So I got to thinking, there has to be a better way. Is there a way to pre-categorize the pixels?
Let's speed this video up a little bit.
That way, I can target just one category of pixels. Then I remembered, you can save the sprite in a way that instead of pixels being represented by color values individually, they can point to a color in a palette. This is called the indexed mode, because the pixels are just index numbers referring to a spot in a palette. So the hair can be color number 1, and the shirt can be color number 2. And color number 1 and color number 2 could be the same. It'll still be distinguishable as 1 and 2. Genius. Now all I have to do is make the shader work based on the index instead of colors. So I looked at Godot's shader document to see how to access the index number instead of colors. And to my surprise, I could not find anything. Surely I'm not the first one to think of this. Surely other people need this functionality too, but no. Now, I could do the same thing and search for Godot plugin for using palette index and shader. But I didn't all into a full-time indie dev and YouTuber life by being sane. After all, this is a fun learning opportunity, and how hard could it be, right? Famous last word. So I decided to make this plugin myself. To start, I chose to focus on the more popular graphics format that I knew had index mode built in, PNG file. Portable network graphics, a format intended to be small for
Did anybody know that's what PNG stands for?
network uses.
I had
And
no
what's more
idea.
impressive is that unlike JPEG, it is lossless, meaning the compression to make it small does not sacrifice any information. This is cool and all, but that means the file isn't just a simple stream of RGB values. It has an elegant algorithm that makes it small and lossless, so I had to learn how to parse this file. I looked up PNG format specification, aka RFC 2083, published in March 1997. I don't know about you, but I haven't had the need to read any specifications like this in a while. In fact, I
This sounds already like it's too much work.
actually never had to read one before. And let me tell you, it
PNG
is
too.
dense. The beginning is simple though. There are chunks, and each chunk starts with bytes indicating what type of chunks they are and how large the chunk is. And depending on the chunk type, the specification explains what information is stored within the chunk and in what order. For example, here's a chunk type called IHDR, and this is a metadata chunk. And the document explains that the first 4 bytes are width of the image, and the next 4 bytes are height, and the next compression method, filter method, etc., etc.
Okay.
Even reading palettes were as simple as just reading a chunk named PLTE. The real complex part, which ended up taking 99% of my time while working on this, is what is called an IDAT chunk. This is where the pixels are stored. And let me warn you, it is about to get technical, but I'll try
Oh,
my best
no.
to explain this as quickly
I thought
and
it was already
understandably as
technical.
possible. So buckle up. PNG uses what's called a deflate compression method, which is 2-part compression. Let's say you have 2 pixels in the image. Here you can see the second pixel is identical to the first. So instead of writing the numbers twice, the compressor will take the second pixel and turn it into 3, 3. First 3 is a copy length, and the second 3 by 3. If you were, and we see up 4, 9, known as the LZ77 compression.
I'm sorry,
But
guys.
we're
I don't really.
not done. Times each of the memory tree is generated what encodes the value down here, is more frequent as the Huffman.
Very good
This
video,
is
though.
only the beginning. Talking about all the struggles I went
Nuts.
through and how to actually implement this in practice would be very tedious. So I will spare you the details
Guys, these B-roll footage is really making me feel uncomfortable.
unless you want to hear about it. If so, type "I am a sucker for pain," give me more down in the comments. If there's enough of you, I will make the video explaining it all in the future. But as for now, this is as far as I am willing to speak on this topic. So finally, I have this beautiful code for parsing PNG files. Mind you, I did this in GDScript no less, because I am truly a sucker for pain. And by now, I know someone in the comment is typing, hey, if you just use C#, there's a library for that. Well, sir or madam, it's too late for that, isn't it? And look, as I said before, we got to learn something new, so it's worth it, right? All right, moving on to the final touch. Shaders in Godot unfortunately do not take arrays as a parameter, so I can't simply hand over the index information. Instead, I have to make a texture with these indices as the color values. Then I can finally add the logic to replace the colors based on the index texture. Now, where do I go from here? You can probably
It's
already
almost-
see all the cool things you could do with it, like applying separate colors for highlights and shadows, or like making color animation for hair only. Look, Bob is Super Saiyan now. Applications are endless, and I'm quite happy with the result. Now, with the recent news and more people migrating over to Godot, I want to start contributing to the community more. So I'll put the GitHub link to this code in the description for anyone to use. Also, I found this one bug in Godot while working on this feature, and I want to try my hand at fixing the bug myself. After all, that's one of the benefits of using open source engine. So if you want to see that, make sure to subscribe and click on the notification button so you don't miss it. And thanks for watching, and I will see you all.
Very interesting. I didn't understand most of it. Still interesting. Cool. Nice. So guys, we wrote our first visual shader. It makes our grass go floppy flop. We need to actually, there's two things we need to do. I want to fix the getting into the water. Best thing to do is use a color strip that matches index and color. They're showing like 90% of that. Oh my god, all the grasses are going floppy flop. Oh my god, all of the bushes have color pickers. Let me take that out of the berry bush. Okay, cool. Great. Okay, let's put some music back on. Yeah, they're very artistic bushes, yes. Okay, let's see if we could do this ourselves. I only want this to... Oh, someone put the Godot shader link. Okay, let's check it out. Oh, yeah, I've seen this before. Water shader, gradient, film grain shader. That's so cool. That's pretty dope. Oh my god. That visual stuff actually more confusing than it helps me. I know, same. Looking at those techniques of messing with pixel colors reminds me of the old game Whizball. It's post-processing. Black glow effect. Why is it static? Why you no use GIF? Stylized sky. Okay. Screen shake. Okay. Chromatic chaos distortion. Oh, that's cool. Analog monochrome monitor. I like that. Liquid mesh. Deep map effect. I've never thought of screen shake as being a shader. Billboard. Oh, yeah. Sprite 3D. That's nice. Fresnel outline. That's pretty cool. Noise offset wiggle. Can you guys... Oh, okay. Dope. Pretty dope. Oh, and this is just rain or snow. Nice. Okay. Awesome. Okay. Shaders being triggered by variables. Godot shaders being triggered by variables. I've done it before. Because I've made a shader with like when you hit a character it flashes. Okay, that's how you do it, I guess. But I guess I wouldn't know how to do that. Oh, so if it's a visual shader, that's it? Uniform bool. But how would I do that in visual shader? Which bool? Like this? I guess I would put it up here. What's up, Snow? How's it going? I think you just declare a thing in the shader. Godot. Oh, dang, girl, you treating yourself today. I think it's the parameter that adds a uniform. Godot variables in visual shaders. Here we are. No, there was another snow. There's 3 snows now. That's Snooey's. Yeah, guys, there's a camera behind me. It's watching me. Okay, cool. Too many goddamn snows. Okay. Godot 3. Visual shader node varying using visual shaders. Variables. Expressions. Oh. I really don't know. Oh, there. Wait, what is this? Visual shader. Search for parameter in visual shader. It's called set shader parameter. Okay. Parameter. Okay, there it is. Boolean parameter. Is windy, whatever. We'll do is windy. Instance. So default value is false. But and then what? I need an if. If a can you not? Pigs scared me. Oh, do I need a different type of if? How's it going? If because this is like for vector. I don't understand. Yeah, I have a cam behind me. In shader, you would put it in a blend and then the parameter control which blend you're using, A or B. Blend. Is windy. Oh, wait. I don't. I don't know how I would do this. Is 0 like false? I don't know. What can be represented by 0, 1? Tolerance. Oh, I guess it's waiting. But this should turn on. Oh, A equals B. No. Yeah, I didn't understand this if. Let's check it out. Godot visual shader if. Okay, let's check it out on YouTube too. Thank you, 844. Probably not. That's when you want to blend now. We're really backseating great. Yes, yes. Godot. Well, let's see if this guy ended up talking about it.
Represent
Masking and image techniques. Controlling shaders. Here we go. Okay. This looks like it might be it.
In our game, we want the player to be able to select a color for their character. So we need to be able to change the replacement color from our game code. Right now, it is hard-coded in the shader. So we need a way of sending data into our shader, and we can do this with a shader parameter. So let's right-click and search for parameter. And we want to give the shader a color as a parameter, so we use a color parameter node. We can give this parameter a name. Maybe let's call it replacement underscore color. And then we connect this to this multiply node where we had the hard-coded color. Now we can go to our sprite in the material section. And here we have a new shader parameter.
Okay, so we should have that parameter. Here. No. Where was it?
Where we can set the hard-coded color. Now we can go to our sprite in the material section.
Parameter not there. I just don't like how there's no input into that. I want to be able to control this, because like right now, it'll do that. But I wanted to control this with a Boolean. But I don't know why we're not seeing the Boolean there. I don't know how this if works. I think we should be doing it here, actually. Maybe let's add node in conditional functions. There's if. Maybe a switch. Switch 2D. Okay. True, false. Okay. True, false. No. Just true. So this is the value. Red. Okay, vector 2. Oh, maybe, yeah, Boolean. Okay, that's better. So this is true, and that is false. And what value are we comparing this value? Oh, this. Oh, god damn it. No, I think it should be. Ah. You need the time node on an output. Why can't I see the variable here though? It's kind of annoying.
And here we have a new shader parameter where we can set the replacement color. But we want to set this parameter from our game code. And
Why? Wait. Oh. I am so confused. Oh my god. Okay, let's hear him talk about this if, because I really don't get the if.
will return a vector 3 center. So when we know this, we can calculate the coordinates of all the 4 vertices relative to the center. And if we look at these coordinates, we can see that the I-coordinate, the node, maybe let's add one of these. So we right-click, we search for if, and we add it.
So Redshift.
Now the if node has 2 numbers, A and B. And the if node will return a vector 3 depending on whether A is equal to B, greater than B, or smaller than B.
So the vector return.
For each of these cases, we can configure what the output of the if node should be.
Would a shader like this be less resource intensive than just wobbling in code with regular vectors? I have no idea.
So let's first plug the y-coordinate of the vertex into the A input, because we want to know if this is negative or positive. But how do we only get the y-coordinate of the position? Because we only have a vector 2 here. Well, we can click this little triangle here to get additional outputs, then split this vector 2 into its components. They are somewhat confusingly named red and green, and this is because of some exponents of it that can also be named blue when we work with the shader language. So for now, we just need to know X and put this into our if node on the A input. The B input we keep at 0 because we want to compare the Y input with 0, and then we can set the output for A is less than B.
Okay. See if Remy is. Yeah, maybe I shouldn't have put that. If this is a weird. Oh, wait. So this is true or false? Oh, okay, wait. I think if okay. So if this is true, it would be 1. Bro. This is like impossible for my brain. Same bit. Hopefully there's a video on this. Godot. Godot. Connect your variables to A, B, and connect you with this. Yeah, I know that, Nick, but I don't know how to set it up with this. I understand what it means, but I don't understand how to set this up. Because I would need the output to be the sign if it's true. If A... would be this, probably. I think it had it here. Oh wait, shader parameters here. Okay, at least we found the shader parameter. That's a start. That is definitely a start. A. So if it's 0, can you just input a float into the value? You're gonna need to break down what you just said because I don't understand. I think a switch node is better. Switch bool. So this value. So this is if it's true. And if it's false. But it's doing it weird. Do I need to put it in here? No. Why is it doing it weird now? I don't know why it's doing it weirdly now. A sign. I'm multiplying. Sign. I know. I don't know. I don't even understand these nodes, Flex. Yes. We're using time to multiply the sign. I don't know why it's glitching out like
for
that.
the input node. So we somehow need to build a vector 3 from components.
What's up, Feta?
To a method sign function. To the function number 0 and tracking 1 point, then return larger than A. We search for sign, and then we edit after time into the sign node, and the sign node into the X component of our vector 3. And if we zoom in by 1, we need to increase this range to be multiplied into this multiply node, and then we multiply by 100.
Let's try to increase the value. This is the value, and if it's true, if it's false. It's just so weird. Switch float. Okay, let's try a switch float. Multiply it again. Oh yeah, you're right. Fragment, you're a genius. You want to use a switch float. One input as the time. Can you explain why this was right? Okay, so now when it's not windy, And when it is windy. I have another question. I gotta comb through 7 o'clock for SQL. That doesn't sound fun. Okay, so currently, well actually let's currently all of them are moving in this like at the same time. How do I get them to move differently? Because shaders, I don't know. I don't think they work that way. But yeah, this is what it looks like in game, guys. Thank you again, Brackman. That's so cool. That is so dope. Location-based offset. Yeah, that's actually a good idea. This is so cool, though. Like, I need an arrow. Sociopath, thank you so much for the follow. I forgot you guys. Forgot you guys could see me. That's kind of weird, guys. Yeah, that's how you go through the door. Don't tell anybody that. This is my house. I made it. There's no collisions, except for the walls. Chop the walls down. 70,000 lines of code. Fetch at the global position from which in the city. Yeah, that's the next question. Yeah, how do you get, there's functions, variables. Oh, input maybe. Input, UV. Let's put some music on. Position. Transform. Rand range. Okay. Are they all gonna go at this? And they're all going at the same time. I know I completely butchered that. I'm a shader idiot. It's gotta be before the sign function. What's up, Knut? I don't know if there are world positions available. Maybe it's in. Oh yeah, that's true. The game can give the position. if we give it let's get access to this through the code first. Yeah, of course. But that's stuff we think about later. Okay, let's see how to get the... True, Minesweeper.
Game code. And this is where our color picker here comes in. We want to select a color with this color picker, crypt. And now when the player changes, sounds a bit like using signals. So let's check the signals that the color picker changed. Color picker.
We need to just see how to get that.
So we can just type material. The material has a function called setShaderParameter, which allows us to change the value of a shader parameter. And as the first argument, the function expects the name of the shader parameter that we want to change. We named our shader parameter replacement_color. So we type replacement_color. Now
set shader parameter. Cyborg, thank you for the follow. That's the one. So we'll get access. We'll do it in ready. Sprite 1 material set. What? Maybe it's just not here? Okay, let's see. I am putting it to this sprite 2D. The sprite 1 is this sprite. Invalid material. There's no material, but it inherits from canvas items, so there should be material here. It's weird. It's so strange. Oh, it's null. Oh, wait. Yeah, maybe after it chooses the random spray because it's choosing. Could be that. Might still crash, yeah. Why is that null? It's just hiding it if it's not. That's why it just randomly chooses to use one or two. But it's getting that shader on ready, and that's ready. That's weird. up, Gilbert? Claro que sí. The Eldritch God. It's just not. That's weird. And there's 10 billion errors. Strange. Add item to scene. Yeah, errors are awesome. Oh, maybe here we could do it. Yeah, what is this sprite? We can do it to this sprite. Sprite hide. What? Oh, yeah, we could do it to this sprite basically. Okay, let's try it again. And it's still no. That is so weird. Oh, because I'm still doing it sprite 1, right? No. Node not found, random sprite 1. Okay. Okay. That is really weird. Set shader param null. But sprite is a sprite and it has a material, no? Now it's saying material is null. Okay, maybe I forgot how the grass works, but what the hell? Yeah, the material could be empty. Because I have these two. Okay, let me make sure. They both have materials. It's just getting one of these. But they should have materials. Sup, Calciero? Kuda Killen, thank you for the follow. And why doesn't it let me get that? Like, that's also really strange. Mr. Eva Rex. Douche basket. Oh shit. Okay, wait. Oh no. I don't like how tight that is. Second. It's good for my health. Cool. Yeah, I really don't understand this. This is... Yeah, resources are very important. And I don't know what the hell is going on here. I know, that's why I have to make it a channel point, because it's healthy. This it does have the material. You see? It has it. What the hell is the problem now? So weird. Nah, ChatGTP doesn't know about Godot 4. You need to buy a subscription to get the latest ChatGTP. Chat. What is the character body node in Godot 4? See? So you guys have premium ChatGPT? Nerds. Alrighty guys, it's stretch time. Alright. Everybody. Alright, we're gonna hug. Oh, stretch to the left. Stretch to the left. Yeah, we're gonna roll the shoulders. Roll the shoulders. Roll them. We're gonna get hot. We're gonna get hot in her. Oh yeah, it's gonna get spicy. Oh yeah, that's better. That is better. It's so weird looking at myself from like different angles. It's strange. It's a yoga channel, yeah. Oh, my right shoulder. Woo! Baller pledge $1 on Patreon. Let's go! Thank you, Baller. Ah. Can I use a shader to stretch? No, that's not how it works. Alrighty. Oh yeah, it is. It's freezing, yeah. I can't stand it actually. No, we're hiding the random sprite. How dare you dawdle. Okay. I don't know why that's not working. Yeah, random sprite is not it. It says and base null, which is material. And the material. Oh, now it's saying it's empty. Well, we could set it via code. Doc lock, thanks so much for the follow. Material. Shader material. Of course I am Frumius. I hate that message narking me. Oh my god. Shader material. So we just have a shaded material with the shader. Shader material. So pass. Shader material. New. Shader. And I'll do it of type shader material. That shader equals I have no idea. Next gen. What does it mean, guys? Can I do that? There it is. Alrighty, is that how we could do it? Via code? It sure is. Okay. So we set it is windy false, and now it's true. Let's see if that works now. Let's go! Let's go! We set it with the material. We set it with the material. We set it with the material. Why does this rock have a... Okay, that at least does. The rocks don't have collisions. Oh no! The spiders are getting me. I know, I should make that 10K actually. The tree does. It's just the Y sword is acting weird. I need to change more polish. I'm glad you started. Thank you, Epic. Okay, I want to do the ocean thing. The reason it's that expensive is because Frumius has 274,000. Oh, it's better now, no? I want to fix this. Okay. I don't know what guitar I'd play. I could do guitar redeems. Fine, I'll turn them back on. Only because it's Friday. But that's not the problem. That's not the problem we're facing, Eileen. I know there's like more efficient ways to do everything, but you know, if it ain't broke, don't fix it. Like my old grandpappy used to say. Yeah, there are some Path of Exile people in here. Path of Exile people, come out of your caves. Caves. I'm sorry, I can't talk. Let me channel points. I don't know if, whatever, I'm gonna turn this on, but I don't know what I would sing. It's on, Doddle. Is it not on for you? By the way, I'm raising it to 15,000. It says it's on here. Look, okay, let me turn it off and on again. It says it's on. I don't know what to tell you. I don't know what to tell you. Canvatron, thanks so much for the follow. Is it making my game lag? Okay. Canvatron, thanks so much. Subbing with that prime. Hell yeah. Where is... Okay, is Wendy? Can you... Okay, whatever. I don't know why it's gone. Let me see if it's gone. There, it's right there. Doddle. Dear, I found you on YouTube and came to sub. Thank you, Cambitron. I appreciate that. Don't, Frumius, don't do it for Evil Rex. Don't do it. He's milking you right now. Don't let him milk you. Okay. Why does it say it's not available?
No, God! No, God, please, no! No! No!
Dragon,
No!
you're about to get banned. Am I milking the viewers? I would be milking the viewers if I said, you want a guitar? You want a guitar? 5 subs. 5 subs and I'll do a guitar. Okay, we need to fix how this works. Oh my God. Of course, Snooey's. I appreciate that, Snooey's. Hell yeah. Seems like you like getting milked up in there. Spadooski. Congratulations. Alrighty, guys. Alright, milk successful. Let's go. Milk has successfully been successful. Alrighty, guys, what song do you want to hear? Let me see if I remember this song. Hype train incoming? Okay, is there anybody pregnant in here? Oh, I wish Ilokimo was here. He just had a baby. Aww. Okay, Whoever's pregnant, this song is for you. Well, she's got a sorry. She's got a baby inside. And hold her belly tight all through the night, just so she knows that she's sleeping so safely to keep her girl. And when she opens her eyes, there'll be no surprise that she'll learn to be so beautifully, just like her mother, this care. And oh, Capri, she's beauty. There is an angel growing peacefully. Okay, I don't remember that one too much, but I think I need to tune this guitar. Where's my phone? It sounds out of tune. Wait. It's really out of tune. 1 second. It's extremely out of tune. Where's my phone? What the heck? My phone disappeared. Oh my god. I don't know how to tune it without my phone. Okay, guys, this is really strange. I have no idea where my phone is. Pizza box. Phone! Wait, can I call myself? No, I don't know how to call myself. Phone! Where are you? Phone! What the heck? I found it. Sorry, guys. Okay, let me just tune this really quick. Let me tune it really quick. My mom is calling me. Hey, Mama, I'm streaming. Hi, do you want to say hi to the stream?
Hi. I heard you lost your phone, so I thought I'd call you.
Oh my god, my mom was watching the stream. Here, the stream can hear you.
Hi, stream.
Aw, thanks. Mom is the true MVP. Thank you, mother. Paul Hunt. Oh, the stream is going crazy. Do you see? Are you on YouTube or Twitch? Go on Twitch.
You're wearing your Trinity College.
Yeah.
I wish we could go go back to Ireland and experience that again. That was fun.
Yeah. Chat is going wild. They're saying you're the mom of the year.
Aw, you're the daughter of the year.
Okay.
Don't tell your sisters.
I'm gonna send them the clip of this stream now. They're calling you Mama Codes. You're officially Mama Codes.
Aw, that's so nice. Well, at least you found your phone.
I have it now. Thank you. All right, thank you, Mama Codes.
You're welcome. I'll talk to y'all later.
Alrighty, bye.
Fun. Bye.
Mama of the year. Hell yeah. Let's go. Okay. That's nice. Yeah, that's her first time basically on stream. There's a tuner here. All right, let's do this, guys. Let me take my capo off. Alrighty, is good. It doesn't sound that good on. Wait. How does the guitar sound? Does it sound bad? Like. I could turn up the sound. Actually, I could probably. Yeah, whatever. Yeah. I'm trying to think what song to do. Mama Codes raised you well. Thank you, guys. I'll sing this Frey song. Happiness is just outside my window. I saw it crash, blowing 80 miles an hour. And happiness, a little more like knocking and on your door. You just let it in. And happiness feels a lot like sorrow. Let it be. You can't make it come or go, but you are gone. Not for good before now, and gone for now. Feels a lot like gone for good. And happiness, well, damn near destroys you. It breaks your faith to pieces on the floor. So you tell yourself, well, that's enough for now. 'Cause happiness blows a shower of sparks. happiness. It's like the old man told me. Look for it, and you'll never find it all. But you are fine. Live your life and leave it. Then one day you'll wake up and she'll be home. 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 She'll be home. She'll be home. And she'll be home. She'll be home. Sorry guys, I messed up a lot. I haven't played that song in forever. But I need to play the guitar more because, yeah. Thank you, Redship. Thank you, guys. I need to practice more. I appreciate it, but I need to play this thing more and not let it just sit in the corner all the time. But I appreciate all the support. Thank you so much for those 5 gifted, Ben Hater. I really appreciate that. More Colby. Yeah, Colby Kaid is really great. Even better with your sub sound as the back. Oh, I didn't have my headphones on, so I couldn't hear that. Oh. Did the sub sounds go off? Yeah, I hi. Alrighty, guys, let's get back to the coding. Let's get back to the coding, baby. Back to the coding. And thank you guys so much for that hype train. Panda Coder, Snooies, Canvatron. I really appreciate it, guys. You guys are awesome. What's to do next, guys? Let's look at the good old book of shaders. But yeah, I need to. The good thing is, because, like, I can't normally play a guitar without a capo. Does your mom and sisters all have good singing voices? My mom doesn't really sing, but you guys know. I once sang with one of my sisters. I have a clip. I could look for that clip. That's when I was in Miami a while ago. But since then, my sister's like, I'm never getting on your stream ever again. She was very nervous. Yeah. Oh my god. You guys asked my sister about Godot. I bet sis is even better at Godot. Are you better at the game engine Godot?
I've never heard of that. Godot?
Yeah. She's so nervous.
It's a game
so
engine for making video games. Oh. Guys.
So yeah, after that she's like, I don't want to come on there ever again. For next year, I have a New Year's resolution to learn an instrument. As a Zelda fan, I choose the ocarina. Awesome. She was terrified, yeah. Streaming's not for everybody. But we did play music together. So that was fun. Jesus. Okay, I guess I closed the one with the music. Second perspective. Second. Jackie is a daughter. And you're the mom of the year.
Aww, you're the daughter of the year.
Okay.
Don't tell your sisters.
I'm deaf. Guys, send it to my sister right now. Now. Send it. I knew it. Oh,
little while
what
ago,
is
this
this?
image was posted to Reddit by a user called Simping is for Chat. Ignoring the user
Simping is
name,
for
I think
Chad.
this image
Wow, Evil Rex.
awesome. And when I first
So
saw it,
nice. I want to
recreated
keep
it, and
standing
while
though.
I did get it working, it was really slow, even at super small resolutions. As you probably know, I've been messing around with shaders a lot recently, and I figured it was time for me to revisit this and get it running in real time. Just a quick disclaimer, this is just how I managed to do it. There's probably a million much better ways of doing this, but I
Whoa.
think it's pretty cool, so I thought I'd share it
What
with
the
you. As
hell?
always, the code for this demo is freely available in the description, so you can follow along and run this project for yourself in the browser. You'll also find a link to
Okay, check out the other clip. Let me check it out. She'll be home. Okay, now I know. Turn off alerts. I don't like hearing my voice. I don't like hearing myself, okay?
The terrain I use for this comes from a height map, which is basically exactly what it sounds like. We can look up a coordinate in the height map and it'll tell us how tall the terrain is at that point. In the past, I've extruded this height map to actual 3D geometry, but often, like in this case, height maps are used in 2D terrain to figure out which type of tile should be placed where. In such a case, there is no 3D geometry to create lighting with, just a flat image of all the tiles, but you can still generate shadows as you can see here. To get started, we obviously need some
I forgot there was another camera, so it's like I can't.
map terrain. The terrain really isn't the focus of this video, so I've kept it really basic and I won't go into too much depth on it. In fact, I've covered this style of terrain generation in a couple of old videos.
That camera's weird.
Here. But for a quick refresher, here's what I'm doing. I'm using some Perlin noise to generate a random value between
Yes, you
0
guys
and 1
know
for
about
each tile.
this.
This value is the height of the terrain, and I can use it to determine the color or the type of each tile. To make sure we always get islands, I'm squashing the noise values the further they get away from the center, which pushes some of the terrain beneath the water level, creating islands.
Cool.
And that's basically all there is to it. I'm saving the height values in an image with the minimum height being black and the maximum height being white, and I'm saving the colors of the terrain in a separate image so that I can pass them both to the GPU when it comes time to figure out the shadows, which is what we're going to do next. To make the shadows, we simply need to darken any region of the image that isn't touched by light. The tricky bit is figuring out if a region is touched by light or not, and we're going to do that inside a shader. If you haven't used shaders before, check out my introduction to shaders video. It covers all the basics and teaches you everything you need to know to follow along with this video. I promise they're not as hard as you think. Our shader needs a few bits of information, and we'll pass it our 2 pieces of terrain data.
So this guy's not using Godot. But yeah, the shader language, is it the same for everything?
The color map and the height map, as well as a 3D vector that'll represent the sun's location. To figure out if the fragment we're drawing is in a shadow or not, we need to know if there's a direct line between the fragment and the sun that doesn't run into any other terrain. The way I do this is create a 3D point from our current pixel's location for the X and Y, and I look up the height for that position to get the Z. I then find the vector that goes from this point to the sun's location, and if we take small steps along this vector, we'll eventually reach the sun. What we can do
This is
check
crazy. Godot supports GLSL. Okay.
each step along the way
that
to
makes
see
sense.
if we're inside the terrain or not. This is done by simply sampling the height map at our current X and Y
Yeah, that's true. Godot does have its own. But it's like, I guess, similar to this GLSL.
position, and if the height is greater than our current point's
I don't
height
think
stored in the
this is
Z,
Godot
we're
at all.
inside the terrain, and we know that the pixel we're rendering is in shadow. And if that's the case, we can break out of the loop. Likewise, if our point Z is greater than 1, we know that we're above the highest terrain, since the height map is in the range of 0 to 1, which means we must be in full light, letting us break out of the loop as well. There's almost certainly a more elegant way of doing this, and if you know it, please let me know in the comments. If you're enjoying the video, feel free to chuck it a like, and maybe subscribe while you're there. Cheers! So we now know if we're in a shadow or not. All that's left to do is use that information to make the image darker in the shadowed regions. And this is nice and easy.
That's
I just
so
use a
cool.
mix function to choose between the normal terrain color and a darkened version on it based on if we're in a shadow or not. And that's all there is to it. We're using a height map to cast shadows on 2D terrain in real time. Obviously, this method has its limitations since
But I don't think Look, I've already introduction to shaders, learn the basics. See, he's using P5. I knew it was P5. Yeah, he's using P5. He's not using Godot. I assume you've seen the official docs for shaders. Yeah, I have. If I remember correctly, Godot shader has some limitations compared to full GLSL? Maybe, probably. Okay, let's put some music on. Today's a shaded day. It's a shaded day. It's a shaded day. Okay, I need chiller music. That's Game Chops. Okay. Okay. Let's go to what is a shader? Getting started. What is a shader? A fragment shader. In the previous chapter, we described shaders as equivalent of the Gutenberg press for graphics. Why, and more importantly, what's a shader? If you already have experience making drawings with computers, you know that in that process, you draw a circle, then a rectangle, a line, some triangles, until you compose the image you want. That process is very similar to writing a letter or a book by hand. It is a set of instructions that do one task after another. ShaderToy is one of the big websites that download shaders. Okay. Like shader scripts? Shaders are also a set of instructions, but the instructions are executed all at once for every single pixel on the screen. That means the code you write has to behave differently depending on the position of the pixel on the screen. Like a type press, your program will work as a function that receives a position and returns a color. And when it's compiled, it will run extraordinarily fast. Why are shaders so fast? To answer this, I present the wonders of parallel processing. Imagine the CPU of your computer as a big industrial pipe, and every task as something that passes through it like a factory line. Some tasks are bigger than others, which means they require more time and energy to deal with. We say they require more processing power. Because of the architecture of computers, the jobs are forced to run in a series. Each job has to be finished one at a time. Modern computers usually have groups of 4 processors that work like these pipes, completing tasks one after another to keep things running smoothly. Each pipe is also known as a thread. This is the book of shaders. Basically copy and paste them into Godot. True. Yeah, we were looking at websites with that. This is a lot of thinking for a Friday. Video games and other graphic applications require a lot more processing power than other programs. Because of their graphic content, they have to do huge numbers of pixel-by-pixel operations. Every single pixel on the screen needs to be computed, and in 3D games, geometries and perspectives need to be calculated as well. Let's go back to our metaphor of the pipe and tasks. Each pixel on the screen represents a simple, small task. Individually, each pixel task isn't an issue for the CPU. But here's the problem. The tiny task has to be done to each pixel on the screen. That means in an old 800 by 600 screen, 480,000 it's definitely Friday. Pixels have to be processed per frame, which means 14 million calculations per second. Yes, that's a problem big enough to overload a microprocessor. In a modern 2880 1800 retina display running at 60 frames per second, that calculating adds up to 311 million calculations per second. How do graphic engineers solve this? This is when parallel processing becomes a good solution. Instead of having a couple of big and powerful microprocessors or pipes, it is smarter to have a lot of tiny microprocessors running in parallel at the same time. That's what a graphics processor unit is. The fractal Brownian motion shader. Oh. Graphic content. What do you want to achieve with the shader? I want to make my game look beautiful. My CPU feels like a big industrial pipe. I'm gonna read it. I'm gonna read it so hard. Picture the tiny microprocessor as a table of pipes that the data. Okay, I'm gonna sit down now. Bye. Picture the tiny microprocessor as a table of pipes and the data of each pixel as a ping pong ball. 14 million ping pong balls a second can obstruct almost any pipe, but a table of 800 by 600 tiny pipes receiving 300 waves of 48,000 pixels a second, 480,000 pixels a second can be handled smoothly. This works the same at higher resolutions. More parallel hardware you have, the bigger the stream it can manage. Another superpower of the GPU is a special math function accelerated via hardware, so complicated math operations are resolved directly by the microchips instead of the software. That means extra fast trigonometrical matrix operations as fast as electricity can go. What is GLSL? What is GLSL? GLSL stands for OpenGL Shading Language, which is the specific standard of shader programs you'll see in the following chapters. There are other types of shaders depending on hardware and operating systems. Here we will work with the OpenGL specs regulated by Kronos Group. Understanding the history of OpenGL can be helpful for understanding most of its weird conventions. For that, I recommend taking a look at this book. Last one, guys. This way we can see if she raises her butt. Oh my god. What's up, Sharper? Why are shaders famously painful? As Uncle Ben said, with great powers comes great responsibility, and parallel computation follows this rule. The powerful architecture design of the GPU comes with its own constraints and restrictions. In order to run in parallel, every pipe or thread has to be independent from every other thread. We say the threads are blind to what the rest of the threads are doing. This restriction implies that all data must flow in the same direction, so it's impossible to check the result of another thread, modify the input data, or pass the outcome of a thread into another thread. Allowing thread-to-thread communication puts the integrity of the data at risk. Also, the GPU keeps the parallel microprocessor, the pipes, constantly busy. As soon as they get free, they receive new information to process. It's impossible for a thread to know what it was doing in the previous moment. It could be drawing a button for the UI of the operating system, then rendering a portion of the sky in a game, then displaying the text of an email. Each thread is not just blind, but also memoryless. Besides, the abstraction required to code a general function that changes the result pixel by pixel depending on its position, the blind and memoryless constraints make shaders not very popular among beginning programmers. Don't worry, in the following chapters we will learn step by step how to go from simple to advanced shading computations. If you are reading this with a modern browser, you will appreciate playing with the interaction. Industrial Llama, thanks so much for the sub. So let's not delay the fun any longer. The fun. The fun. Okay, let's just look at the hello world. Come on, it's just hello world. How bad can it be? Why does it smell like pizza? I didn't eat pizza. What are you talking about? We're reading the Book of Shaders. She's a witch. Pizza. Where she go? Pizza. Oh my god. Chat is crazy. Alrighty. So yeah, this I think I could change and it'll output it. Yeah. Cool. She's a witch, burn her! Usually the Hello World example is the first step to learning a new language. It's a simple one-line program that outputs an enthusiastic, welcoming message and declares opportunities ahead. In GPU land, rendering text is an overcomplicated task for a first step. Instead, we'll choose a bright, welcoming color to shout our enthusiasm. If def GLES precision medium float and if uniform float u time void main GL frag color equals vec4. So I could change it like this. Okay. What is that? I don't think... Do you think this will work in Godot? Like, straight up? come here. Tayson, Nathan, thank you for the follow. See? Like that. See, it doesn't work. I don't get it. I think we need to get color. Dotto, am I making albedo? Libido. It's libido, you said it wrong. Oh, do I need to put it in caps? I thought you were just yelling at me. It's okay. Okay, so it's not the same thing, okay? Godot is not GLSL. It's its own thing. Godot has its own shader tutorial and Fragment instead of main. Oh, that's true. Oh, now it's... Oh. Oh, there we go. We did it. We did it! We converted! But only for specific advanced uses. Okay, we did it! Hello, world! Let's make this 1.0. Oh my god. Cool. Can I delete this? And will this still work? Yeah. Cool. Jackie is using Godot creating images. Someone asking. Yeah, the grass animation has the same timing because I know no shaders and I need to offset them by their position or something. Yeah. But we're getting somewhere, guys. A color is born. It's all good, Leet. You get a few nifty built-ins, but honestly, I have for now mostly converted visual shaders and then went on. Yeah, visual shaders are the bee's knees. Godot is awesome. I wish my college would use it instead of Unity. Oh, I'm so sorry to hear that, Industrial Llama. That sounds horrible. Squidorn, thank you for the follow. Alright. If you're reading this book, you are a sucker. No, I'm just kidding. In the browser, the previous block of code is interactive. This means that you can click and change any part of the book you want to explore. Changes will be updated immediately thanks to the GPU architecture that compiles and replaces shaders on the fly. Give it a try by changing the values on line 8 Although these simple lines of code don't look like a lot, we can infer substantial knowledge from them. Shader language has a simple main function that returns a color at the end, similar to C. So in Godot, we use Fragment. The final pixel color is assigned to the reserved global variable GLFrag color, and in Godot we use color in all caps. The C-flavored language has built-in variables. Now I gotta go, it's 3 a.m. Alrighty, next gen, thank you so much for coming. Have a good night. Did you make the pixel art? Some of it, not all of it. I have someone helping me out. You could, Industrial Llama, you could check out the YouTube. I literally just released the devlog yesterday. Thank you, Volmanter. Appreciate that. Color, you got to shout it in case GPU is hard of hearing. Has all the information. Nice. Good to know that. Thanks, Mike. This C-flavored language has built-in variables like GLFrag color, functions, and types. In case we've been introduced to Vec4, this stands for four-dimensional vector floating point precision. Later we will see more of types like vector 3 and vector 2 together with the popular float intent bool. I am hedging my dislike of Unity since 2010. Always had a problem with the pricing. Yep. If we look closely to the Vec4, we can infer that the 4 arguments respond to the red, green, blue, and alpha channels. Also, we can see that these values are normalized, which means they go from 0 to 1. Later, we will learn how normalizing values makes it easier to map values between variables. Why do I have huge lung? Oh, yeah. Followed you on YouTube. But I was in class the last few days. No problem. So that's cool that you're studying game development. Another important C feature we see in this example is the presence of preprocessed processor macros. Macros are part of a pre-compilation step. With them, it is possible to define global variables and do some basic conditional operations with if-def and end-if. Let's look at the Godot shaders. Introduction to shaders. This page explains what shaders are and it gives you an example. Oh, yeah, cool. I've already done this one before. They have like a converting GLSL. This document explains differences between Godot shading language and GLSL and gives practical advice on how to migrate shaders from other sources such as Shader Toy and the Book of Shaders. That's what we're doing into Godot shaders. For detailed information on Godot's shading language, please refer to the shading language reference. Let's just check that out. Cool. GLSL. Godot uses a shading language based on GLSL with the addition of a few quality of life features. Accordingly, most features available in GLSL are available in Godot shading language. There's a fantastic intro to shaders video by Kisha on YouTube. I think would be really nice to learn. Not only were we on this channel already? Thank you for the advice. I think we might. Oh, yeah. Oh wait, was that with that one? Oh, okay. No, I haven't seen this one actually. 22 minutes. Oh, that comment kind of sells it. This is probably the best shader introduction in YouTube. It's now one of the first results for shaders. So you have seen it. But I had a blast customizing the shader, also converting. Cool, okay, let's check it out. Let's check it out. It's only 22 minutes.
Have you ever looked at a breathtaking digital art piece and deeply wondered how they created that? There are many different approaches to digital art.
Is the sound good, guys?
But shaders might be one of the most powerful and versatile when it comes to creative coding. Shaders are like the paintbrushes of the digital age. They allow you to turn a blank screen into a stunning animation in real time, and they're responsible for the stunning visuals in some of your favorite video games and movies. They can be used by creative developers in order to make 2D and 3D renderings exclusively using code, their imagination being the only limit. Shader art coding is all about using mathematical functions and algorithms to manipulate pixels and create incredible visual effects. It's a unique fusion of art and science, where creativity and precision collide to produce something truly mesmerizing. But what are shaders, you may ask? In essence, shaders are small programs that run on your graphics card and are responsible for calculating the color of each pixel on a canvas. Shaders work by taking inputs,
Why are you guys laughing?
such as the position of the current pixel, and using them to calculate a single final color using
about Mr. Evil,
the
right?
OpenGL shading language, or GLSL in short. It can be seen as a mathematical function that maps a 2D coordinate, the pixel's
It sounds like an AI.
position represented as X and Y, to an output color which in computer graphics is represented by a red, green, and blue channel. This function is computed in parallel for every pixel on the screen, which means that shaders can perform millions of calculations per second to produce stunning real-time graphics. Since discovering shaders about a year ago, I've also made some of my own. It's really fun to learn a new computer graphics technique and make a shader about it.
Crazy.
There are so many topics to learn from and so much space for discovery and original creation that it's impossible to get bored. While they're great at rendering stunning 3D scenes and even 4D for the particularly brave developers, shaders also excel at rendering 2D images and animations. They usually run blazing fast compared to some heavy 3D shaders that require more performant GPUs and compute power. For over a year now, I've been sharing my own trippy animations online, mostly in 2D, in order for shader coding
Are there any games out there that are just shading?
to get known by a larger audience. Doing so, I've received many requests for tutorials and explanations about how to create such visuals using code. In this video, I will walk you through the creation of this shader animation from scratch to give you some insights about how to start making digital art using shaders. Additionally, I will provide some useful references and tools that can assist you on your artistic journey and that will be listed in the description.
Damn, that's cool.
I assume a basic knowledge of programming, but don't worry if you don't know anything about code. I'll explain every step of the process, including the mathematical aspects, using visuals that, by the way, are also made with code.
This is like 3 blue, 1 brown of shaders.
If you want to follow along with this video, you can head over to shadertoy.com. It's a platform where you can easily start writing your own shaders and share them with others, and it's a mine of inspiration and knowledge about computer graphics and digital art. I will start from the most basic shader that gets automatically generated when you click on New. Actually, I'll remove all of this to explain from the very beginning what is going on.
Yes, I will share the link. One second, I'm gonna get my drink. And I'm getting cold, so I need to put something on. I wish I had a hot tub. That would be so refreshing.
Each shader is defined inside the main image function and has only 2 parameters. Frag chord is the input parameter. It is of type...
But I wouldn't stream on that. I would just chill. Oh my god, imagine playing video games in a hot tub. Oh!
Vec2, meaning that it's a vector containing 2 values, the x and the y coordinate of the current pixel. Frag color is the output parameter, and it is of type Vec4 because it holds the red, green, and blue channels as
awesome, Panda. I suggest you look for a pixel-specific shader reason.
well as an additional alpha channel which stands for the transparency of the pixel. Let's assign a value to that output parameter. Here we set frag color to a vector of 4 components using the vec4 keyword, then specifying each component's value. The fourth value is the alpha channel. It has no effect in ShaderToy, so I'll keep it to 1. In GLSL, the output color is
Thank you for the sub, Gam.
normalized, meaning that each channel ranges from 0 to 1. By setting all channels to 0, the output is full black. Remember that this code is ran for every pixel to determine its color. Here, the output color is a constant, so it will display a uniform black color across the screen. Similarly, by setting all 3 channels to 1, we can display full white. By playing with all the possible values for all 3 channels, we can produce millions of unique colors. I should also mention that there is a nice Chrome extension for ShaderToy that provides some useful features like this color picker that allow you to convert colors to vectors easily. It's called the ShaderToy unofficial plugin. Now, let's use the value of the input parameter in order to start seeing some better things than a uniform color. The range of frag chord is dependent on the size of the canvas. For instance, if you're rendering on a 1600 by 900 canvas, X will range between 0 and 1600, and Y will range between 0 and 900. However, when working with shaders, we'll usually want to have these coordinates in clip space, ranging from -1 to 1, so that they do not depend on the current resolution of the canvas. So I will create a new vector called UV, which will contain our transformed pixel coordinates. The first step is to normalize frag chord so that its components range from 0 to 1. For that, we simply need to divide it by a vector containing the current canvas resolution. Fortunately, there's a global constant provided by ShaderToy called
It's probably different in Godot.
resolution. It's a vector of 3 components holding the current canvas.
Yeah, my shower is currently broken, and I don't even get such hot water. It's very, very painful. I'm like forced Wim Hof.
Size in pixels. The first 2 components are the width and height of the output texture, and the third component is the depth and is only used when rendering.
Yeah, that was a very good explanation. Thank you, Volmancer. Why can't I say your name? Volmancer.
Rendering to 3D textures. As we're rendering on a 2D canvas, we won't use the depth here, and the .xy syntax is used to isolate the width and height components of the resolution, so that the division happens between vectors of the same size.
The resolution in Godot. Oh, okay, so look, frag color, frag chord. I resolution equivalent is there. There we go.
I'd like to pause for a second here to discuss
How do you get a baby alien to sleep? You rocket.
an important concept widely used in GLSL called swizzling. Writing iResolution.xy is equivalent to creating a new vec2.
It sucks that Godot doesn't use exact GLSL. Some shaders use weird macros, and it's super painful to convert them to Godot. Does Unity use the normal GLSL?
And assigning to it the X and Y components.
Captain One, I thank you for the prime sub, yeah. Sorry.
Of iResolution, respectively.
Alrighty, Industrial Llama. Have a good evening. Good luck with your school and everything. Thank you for coming. Unity's DirectX.
This concept can be extended further. For instance, if we wanted to create a new vector containing only the Y and Z components, but in reverse order,
frag chord, that's the in. Okay.
We could simply write iResolution.zy. These swizzling syntaxes are valid in GLSL and allow you to easily create, arrange, and reorder vectors into new ones. It's also important to note that when performing operations between vectors that have the same number of components, it acts as a shortcut, applying the same operation to every corresponding component of the vectors.
Can we change Riz to Swizzle? Yo, bro, you got the swizzle. You pick her up with that swizzle.
So let's check if it worked. I will display the X value of this new vector in the red channel only, keeping green and blue to 0. We can observe a red gradient that aligns with the fact that the UV.X value linearly ranges from 0 to 1 as we move from the left to the right side of the canvas.
Oh, that is cool. I want to convert that to Godot. What happened to the top view game you were working on? Logcraft is here. That's what we're doing. We're making the grass dance, but now we're working on shaders, getting a freak on. Working on shaders, getting a freak on. Yeah. GLSL is DirectX. Then it translates to GLSL. You sound smart. You like my tunes? Thank you. Garou shading, same eye opening experience 30 years ago. It's really nice. Okay, void main image. Wait, let me see. Does main? I think it's the same. Okay, guys, we're gonna convert this. So vec2. See, there's none of that. If I write fragment, can I just do out 4? I don't think I can do that. Frag color to color. So this is just color, right? And frag chord. Redefinition of color. Slater, goddammit. Anybody help? How's it going, Slater? Wouldn't this all be redundant when you have to reprogram it based on the wind direction? I'm not right now. I'm not doing this wind direction. I'm just learning shaders. Can't you leave me alone? Vec2. So it doesn't like that I'm redefining color. Oh, wait. Oh, wait. I don't know. Yeah, I'm not so sure about this. Or UVX. Oh, woman answer. Oh no, yeah, it is. Because it doesn't like that I'm Okay. I'll try it without arguments. Frag chord is frag chord divided by screen pixel size. Oh wait, I also forgot the semicolon. Wait. Oh, it's just .xy. It also have this. Or maybe no, because here it's like XY, but the weird thing is it's like the equivalent is this. Can also pass in manually. Find a uniform at the top. That's true. That is true. Frag color, frag chord. Manually. See, I don't get why it's 1.0. Yeah. Strange. Invalid arguments to operator. Vec frag chord. I was thinking that, but let's see. Okay, that worked, but it's not doing the gradient, but let's... Oh, yeah. Then we have to do here, UV X. And let's here, we'll do 0.0. 0.0. Should be a gradient. Yeah, it should be the gradient. There it is! Awesome. Thank you guys. Thank you, Mike. Thank you, Island. It's so awesome, guys. Like, I have YouTube and Twitch helping me. Like, you guys are freaking awesome. You guys are awesome. Okay, cool. Awesome, guys. Thank you. We did it!
In a similar way, if we display the y coordinate this time in the green...
Okay, I'm gonna do it with blue. So we'll do 0.0, and then here we'll do UV dot Y. Yay! But if we want it the other direction, oh no. I don't think it could do that. Oh, because Godot is Y positive is down, that's why it's like that. What if we do negative? Oh no, it doesn't because it's normalized. Someone feel sad for me, please. I got let go this week. Oh, sorry to hear that's later. Oh, 1 minus. I know, I have ChatGPT watching the stream. I like green color better, actually. Yeah, 1 minus, that doesn't work. Maybe 1.0. Oh, there we go. Yeah, you have to do 1.0.
Panel only, we'll see a green gradient going from the bottom to the top. Now, let's display both components at the same time in the red and green channels, respectively. The bottom left corner.
That's cool. U, V, X. That is so cool. Slater, have you considered moving? San Francisco sounds like a very difficult place to live.
Is black because both components are 0, and in the top right corner both red and green channels are at 1, which produces yellow. All other pixel colors contain nuances of red and green that visually represent the value.
Maybe if I do 1.0 minus, we'll get that black. Yeah, ours looks different. I wonder why. UVX. We have UVY, but of course 1 minus. It's weird. We don't have that black.
Of the UV coordinates. Note that in GLSL.
Let me just see if... let's try 1 minus. Oh, there. Yeah, now we have it. But we need to... Yeah. It's not super black, but whatever, I'll take it. Oh, wrong video. Oh.
We can simplify the following expression by merging the first two channels into one and directly writing UV as it contains two.
Wow. Okay, whatever.
Values. Now let's start to transform the space in a way that is more convenient to work with. Right now, our UV coordinates range between 0 and 1, meaning that the center pixel coordinate is 0.5.5. But it would be preferable to have it exactly at 0, 0, so the center of the canvas matches with the center of our coordinate space. In order to fix that, we can first subtract 0.5 to each component of our UV vector. This will shift the space to the up.
Okay. Okay. Yeah, I guess that does kind of look like his. It looks slightly off. Yeah, it's weird. It's very strange. Yeah, the preview does look super bad. Did you know you can move windows between screens using window Shift left. Nice. Woo! Sorry. I realized you guys can see it. Oh my god, that was fun. Window D will instantly hide show all windows. I'm afraid of Oh. Mom walks in. Oh.
Right and effectively center it.
Use it on the sprite. That's what I was thinking. Let's sprite. Jackie, what even made you decide to have a 2D? I wanted to get funky, you know. I think okay. Oh wait, I actually have something. I have a pixel. There we go. What? Why does it matter? Oh, because it's the screen? Is that normal? Is that normal, guys? Okay. I'll just think yes. Okay. But let's see if it is yellow when I do minus. Okay, well, it's not becoming yellow again, which is good. It is becoming yellow, okay. Learning shader stuff, dude. Oh, because I would have to, yeah, I get it. I would have to use that here. UV. Nope. Or UV. Now it's broken. Just UV Godot computes it for you. Color equals vec4 UV. Oh, okay, yeah. So is this doing anything? That's not. What if I want to flip it? So I would do. If I wanted to flip it, I would do this. Constants cannot be modified. So how would I flip it? Then I can't manipulate it. Am I manipulating it here? Nope. Okay. And then here I would do minus 0.5, right? Yeah, okay. That makes sense. Okay, thank you guys for all the help. Use UV in color, not UV. Okay. UV. Confusing variable name. So what is this UV? Guys, stop with the Windows shortcuts. UV is built in pixel position. UV 5. Can I do? I can't do plus. I can. Okay, let's get back to the video.
However, the corners of the canvas now range from minus 0.5 to 0.5 instead of ranging from minus 1 to 1 like we wanted at the start.
You can read about it in the Godot docs and the canvas item shaders. Thank you. Void fragment back to UV equals. Thank you, Aylin. Color is the RGB and texture is the sprite. We're not using texture.
Start. To achieve this, we can multiply the coordinates by 2, resulting in the center remaining at 0, 0, while doubling the UV values of all other pixels to ensure they fit with.
Okay, let's try that. Cool. Okay, wait, I want vec2 UV equals 2 times UV minus 0.5. Perf. I like that. Nice. Whew. No, Salvador, no. Let's get Godot. Is frag chord per screen and UV per... Mike is asking, is frag chord per screen and UV is per image?
Within clip space. As a final step, we can clean up the code by condensing it into a single line and eliminating the parentheses. Now that we have this foundation, our objective will be to write instructions based on the current pixel coordinate to display interesting renderings. There are a multitude of GLSL functions at our disposal, and in this tutorial, we will explore a selection of them. We will start by exploring the length function. This function takes a vector as its input and calculates the magnitude of that vector. Essentially, it calculates the distance between the vector and the origin. Since we have centered our origin, we can utilize the length function to calculate the distance between any given pixel and the center of the screen by passing in our UV vector. This can prove to be extremely useful when creating complex and dynamic renderings. I will create a float value, which unlike vectors contains one single decimal number, and assign the length of our UV coordinates to it. By setting the red channel of the output color to this value, we can observe a radial gradient.
Oh my god, that's so beautiful. Oh my god, okay. Float D length UV. Doesn't like my float. D is a single float. You need 4 floats. I need 4 floats. Vec. Vec 4 only has 3 floats. No, the color line. Oh, okay, got it. Oh, okay, I get it. Oh, Jesus Christ. I get it. Okay. Jesus. Jeez. Okay. This is pretty easy stuff. Sorry, guys. My bad.
It represents the distance between each pixel and the origin of the canvas.
I'm glad this is being recorded. I'm gonna look at this VOD later.
Transitioning from black to red. Alternatively, we can assign this value to all 3 color channels, creating a grayscale gradient.
Let's do that. That's cool. Okay. Touche. Yeah, Mars.
But before continuing, we need to address an issue with the current code. Everything works fine because our canvas is a square and has an aspect ratio.
Yeah, that negative 1.0 minus D. Ooh. Eee. Oh, so it's the inverted black. That's all inverted. That makes sense. Salvador, thank you for following. Please don't die by eating leftover Thanksgiving dinner.
Ratio of 1, meaning the width and height are equal. However, if we were to change the aspect ratio by making the canvas wider, for example, we would notice that the circle gets stretched horizontally. This occurs because our UV values always range from 0 to 1, regardless of the canvas's width and height. To fix this issue, we need to multiply the x component of our UVs by the current aspect ratio of the canvas, which is its width divided by its height. This adjustment ensures that we avoid any unwanted stretching or distortion effects, even when dealing with different canvas sizes and aspect ratios. To really be efficient, we can combine our previous UV transformations with this new fix and rewrite it on a single line using basic math simplifications. Now, I will subtract 0.5 from this distance. The expression...
Let's do it.
length
Dr.
UV
Wolf.
minus 0.5 actually represents the sign distance function of a circle with a radius of 0.5. A sign distance function, or SDF, is a term used to describe a function that takes a position in space as input and returns the distance from that position to a given shape.
Aww.
It is called signed because the distance is positive outside the shape, negative inside the shape, and exactly 0 at the boundary of the shape. You can find distance functions for a lot of shapes or even make your own. I've linked in the description this article that provides a collection of useful 2D SDFs for various shapes, and this website in general is also a mine of useful tutorials about shader coding. So the gradient we're observing represents the signed distance to a circle with a radius of 0.5.
The video's about to get
values
nuts.
are positive outside the circle's edge, which creates a gradient, but they are negative inside the circle, resulting in black. To verify this, let's take the absolute value of this distance using the abs function. This will convert the negative values to positive, and now we can observe that the distance...
Oh. D abs D. Oh.
Distance increases as we move further away from the circle's edge in both directions. To achieve a sharper transition, we can utilize the step function. It accepts two input parameters, a threshold and a value, and its output can only have two states. It will always return 0 when the value is less than the threshold, and 1 otherwise. By applying the step function to the D value with a threshold of 0.1, all pixels with a D value less than 0.1 will be assigned the color black, while all other pixels will be assigned the color white, creating a distinct ring shape.
Ooh, baby. No. Oh, it's D? Oh, it's D. Sorry, I misread it. Yeah. Woohoo. We got a circle. Circle. What if we do that? Oh. 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 What if we do that? Hey. Oh. Oh. Yee. Our boy is
Shape. However, if we want a smoother transition between black and white, we can utilize the wonderful and magical smooth step.
There's gonna be a test at the end of this stream, so you guys better be paying attention. Better.
Function. It is similar to the step function, but this time takes two threshold values. It assigns the color black when the parameter is below the first threshold, and white when it exceeds the
Alrighty, Lupo. What is the step of the D?
second threshold.
What's the threshold of the D?
Within the threshold range, it smoothly interpolates the values between 0 and 1. This gives us complete control over the range and sharpness of the transition. By using this function, we can achieve a seamless gradient from black to white between the values of 0 and 0.1. Now, instead of subtracting 0.5 from the original distance, I will apply the sine function to it in order to create a radial repetition of the rings. Currently, it only displays a single dot because the sign of a value between 0 and 1 is very close to the original value, resulting in minimal change. However, when we increase the frequency of the input value, we can better see the oscillating pattern of the sine function, which ranges from -1 to 1, and it allows us to generate repeating rings around the center of the image. Note that multiplying the distance by 8 before applying...
Oh my god, that's so cool. Oh my god, it's like echo communication, right? Echolocation. Okay. We're like bats. Hell yeah, Darby Baker. Sorry, I've been streaming for a while. Why does he have Why does he have 8 points and it doesn't, there's not even an O? That's confusing. Oh. Smooth step. We broke it, boy. Oh, this. There's no more this. Yes! Yes! Let's go! Yes!
The sign function stretches the space and alters the color intensity, requiring a corresponding division of the output by the same factor. One interesting
no summer school for you.
Characteristic of the sign function is its repetitive nature. By introducing a time component and offsetting the distance before applying the sign function,
I know, I want to make it move.
Create
my time, my time, my time, 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 time. Come on, move! Move, yeah! We mastered the shaders. We mastered the shaders. It's moving. It's moving. Is moving. We don't want that. We mastered it, yeah. She's gonna open a black hole. Wait, guys. Kind of cool. Okay, it's fine. Whatever. It's gonna be like that. It's okay. Okay, I want to do cosine. Yee. Thanks. I want to do tangent. Ooh. Okay, wait. I want to try something. Famous last words. Famous last words. Float A equals length UV A I fucking hate you, Donald. Go fuck yourself. I apologize for my Profane language. It's not who I am. Why didn't it work? Oh, because they're the same thing. Doi. Oh, yeah, that's what I wanted. Oh, baby, baby, baby. Oh, yeah, that's what I wanted. Let's try like 4. Oh. Oh. Oh, yeah, baby. Oh. Ooh. It's faster. Okay, now we need another one. Now we need like a C. Okay. Thank you for the follow, Andy. Oh, see. Yeah, okay. Let's try 2. That's so cool. I don't want white though. Oh, yeah. Hype train is close. Ah. Andy, thanks so much. I appreciate that. Whoa. Hell yeah. Oh, baby. Baby. Sorry. No problem. Whoa. Oh, that is so cool. Okay, what if they're all tangent? Oh. We tripping, guys. We tripping. Start learning. Do you guys think it's better to start learning shaders by doing this kind of videos, or better doing practical skills like that? Because in video games, I don't think I'll ever need to draw circles. I think it's good to just do these exercises. You know, and just get, the more you use it, the more you get comfortable with it. It's not about, oh, that is so cool. Alrighty, guys, let's carry on.
Infinite loop of rings that continuously shrink towards the center. In this case, I am utilizing a global constant called I-time, which is an ever-increasing float representing the number of seconds that have passed since the beginning of the animation. Now that we have a moving pattern, let's focus on improving the visual aspect in colors. I really like to use neon colors, and the inverse function, 1/x, is perfect for achieving that aesthetic. Instead of calculating the final color using the smooth step function on the D value.
So here's the video for those interested.
I will take the inverse of D. As a result, the screen will become entirely white. So let's take a closer look at the graph of the function to understand what's happening. The graph shows a curve with extremely high outputs for low input values that gradually diminishes as the values increase. Since we are working in clip space, any output value greater than
Thank you for the sub, Gavin.
1 will be displayed as white, and the curve tells us that this is happening if we're taking the inverse of any number that is less than 1. However, after passing through the sine and absolute functions, d now ranges strictly from 0 to 1. Consequently, the output can only ever be white. To address this issue, we can scale down the inverse function to ensure that the falloff is visible within our desired range of 0 to 1. It's still a bit much, so let's scale it down even further, and now we can see a pleasant glow.
Oh. What did he replace with that, though?
Emanating from the ring.
Okay. Dar Baker, thank you for the follow. No, he still has abs. He did this smooth stuff, I think. Oh, divided by D. Oh, that is cool. Dang it, every time I want to click A, I type 1. Oh yeah, I was basically doing it, just a different way. Whoa! Oh my god. That is so cool. Wow.
Rings. Now,
the trick is to distract your mind before you hit the ground.
let's introduce some color into the composition. I will create a new vec3 variable that will initially contain red.
Yeah, the VOD is saved on Twitch and YouTube. To fly, you just throw yourself to the ground and miss. It's hard to keep track.
By multiplying this color variable with the value of D and making it
That's a good idea,
the new shader output, the black areas will remain black, while the white areas will be tinted with the corresponding the black area variable with the value of D and making it the new shader output. The black areas will remain black, while the white areas will be tinted with the corresponding color value. Also, here our calculations are not limited to the 0-1 range. We can intensify the colors by setting certain components to higher values. In this case, the blue channel has the highest value, which produces a vibrant blue tint in the final result. To add even more variety to the colors, I will use a very nice function that you can also find on the previous website, and that allows you to create infinitely various color gradients using the power of trigonometry. It produces a color.
Honestly, my attention span is better when I'm streaming because it's like I can't get distracted. Everybody's watching me, so don't worry,
four
Doddle.
Control parameters of type vec3, which are passed as inputs. These parameters dictate the composition of the gradient, enabling you to customize the colors to suit your preferences. While the function may appear complex with its total of 12 parameters, another website exists that has a user-friendly interface, allowing you to visually create your own palettes and gain a better understanding of how the function operates. After playing for a bit, I found a specific palette that I like, and I can use the values provided at the bottom of the page to update my code. These values correspond to the A, B, C, and D parameters in our palette function. Instead of passing these parameters as inputs to the function, I will declare them directly inside the function by creating 4 new vectors.
Guys, because we're in 2D, it looks like the circles are like merging together, but if this was 3D, they would just be going like in this direction. Guys, I promise I'm sober.
That correspond to the palette I created. With this modification,
and if it was in 4D, it would basically be going like this. It would be going like this. You see my arm? You see my arm? That's like this is the 4th dimension.
I can replace our constant color with the palette function. It takes our original distance to the center of the screen as input before any transformations. This simple adjustment already adds a captivating and dynamic range of colors to our composition. To enhance readability, I will hide the palette function. Afterward, I will proceed to adjust the input to the palette by adding a time offset to it. This modification will bring additional dynamism to the colors, as the gradient will continuously shift and evolve.
Oh my god, okay. Okay, let me just... Oh, Jesus, he's going further. Maybe I could do D equals D plus time. And let's do that for each one. ¿Pero por qué? Okay. Okay.
To the colors, as the gradient will continuously shift and evolve. Now, let's introduce spatial repetition using the fract function, which is perfect for this purpose. The fract function simply returns the fractional part of its input, extracting only the digits after the decimal point. As a result, its output ranges from 0 to 1.
Oh,
but even if the space has been repeated, it's
time greater than 1. So then what if we divide by a point? No, yeah, it wouldn't work. Can you print? Okay, whatever.
Seems that something is not working as expected. To understand the issue, let's display back only the value of our UV variable. We successfully achieved repetition by creating 4 smaller versions of our original UV coordinates. However, each repetition is now confined within the 0-1 range instead of the desired clip space. To resolve this, we can apply the same solution as before, scaling the UVs first and then subtracting 0.5 to center them. We finally have nicely repeated the space, and we can also shorten all these operations into a single line for brevity.
Wow.
Now, D represents the local distance relative to the center of each repetition, but I'd like to keep track of...
Guys, my brain, when I get this tired... I'm sorry, I just come up with memes in my head.
D represents the look
it's like
of these operations into a single line for brevity.
I just thought of a meme of like a guy saying, "Do you want the D?" and then him saying
D.
And then him saying
Now, D represents the local distance relative to the center of each repetition, but I'd like
So you want the local distance centered at each repetition?
to keep track of the original distance to the center of the canvas. I will create a new vec2 called UV0
Oh my God,
and
I'm
assign
sorry,
it the value
guys.
of our UV coordinate.
It's only 9:30.
Before space repetition has been applied. This will allow us to replace D inside the palette by the length of our original UV coordinates, which will break the local gradient repetition. It's now time to add the final touch that will give our composition its fractal appearance, iterations. Before we proceed, let's slightly rewrite the code for what will follow up.
Oh
I will
my
create
God.
a new vec3 variable called final color and initialize it with black. Instead of updating the call value directly,
Yeah,
I
after
will
this
add the
video,
result
I'm
of this
gonna close
operation
this
to our new color variable. Finally, we will output this final color as the result of our shader. This modification doesn't change the visuals, but it sets the stage for adding iterations to our code. To achieve this, we will utilize a for loop, which is a common algorithmic structure found in many programming languages that allows us to repeat instructions. We will encapsulate our entire color calculation code within this loop. At this stage, this simple loop won't produce any visible changes in the visuals, as it will exit after just one iteration. By increasing the number of iterations, we can observe the emergence of additional layers and intricate details in our fractal pattern. However, as the complexity intensifies, it may become visually overwhelming. To mitigate this, I will reduce the frequency
Is this what DMT is like?
of the time offset. Iterating this code generates interesting patterns because each iteration involves scaling and repeating the space using the fract function and adds the resulting
Aquí es Trujillo.
colors together. However, the perfect matching of repetitions caused by multiplying by exactly 2 makes these repetitions match up a bit too well. To introduce more visual interest, I will break this symmetry by multiplying with a decimal number instead. Now, I will make use of the exponential function to increase the variations further. I will multiply d, which is the local distance to the center of each repetition.
Yes, I want the D. You want the logo?
By an exponential function depending on the global distance to the center of the canvas. To try and understand how this works, I will make use of yet another website called GraphToy that was specifically designed to graph GLSL functions. I will display the identity function as a reference along with the exponential function. Actually, we're interested in the exponential of -x. We can see that it displays a similar behavior to 1 over x that we used earlier, but this time doesn't go to infinity at 0. By multiplying the
to infinity and your mom
original x value with this function, we introduce a smooth and distinctive behavior to our final curve, which blends well with the other effects in our current animation. Considering the current brightness intensity, I will further reduce the fall-off of the inverse function to achieve a more balanced effect. Additionally, let's explore the idea of incorporating I into the loop's calculations. This will introduce additional variation to each layer. To achieve this, I will include I as part of the input to our color palette function, resulting in slight color offsets after each iteration. With the improved visual quality, I believe it is appropriate to introduce an additional iteration to enhance the creation of smaller details. As a final touch, let's utilize the power function to enhance the overall contrast of the image. When the input ranges from 0 to 1, the POW function effectively accentuates the darker colors closer to 0, while having a lesser effect on the lighter shades. Although taking the power of 2 may seem excessive, smaller values such as 1.2 can significantly improve the contrast and visual impact of the composition. We could go on and on, introducing new functions and new variations to our animation as the GLSL language offers limitless possibilities. But I'm happy with these results, and sometimes it is also important to recognize when to pause, take a moment to appreciate what we have created, reflect on what we have learned, and approach new ideas with a fresh and blank canvas.
This guy literally just came to YouTube, dropped this banger of a video, and I was like, all right, I'm out. Wow. Thank you, Volmancer, for recommending this. Understanding I'm struggling, but trying to come up with something like this myself is making me feel like an amoeba. Yeah, guys. I don't think my brain can handle anything anymore. But I really appreciate y'all spending your Friday with me. It's been great. 5-hour stream. Hell yeah, let's go. I have to go. My brain is like saying no, 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 no. But yeah, guys, really appreciate y'all. I will be back next week as per usual. Yeah, we'll do some more shading stuff. I need to program, you know, our little dude going into the water. Excited for the next devlog. So I learned shaders and had to make the game all hard. No, I won't do that. But yeah, guys, I released a devlog yesterday, so if you want to check that out, that would definitely be great. I will put the video in the description. Here it is. You can check out the video. And I'm gonna be heading out, guys. I'm gonna go to bed. I'm gonna go home, probably play some video games, and then pass out. That sounds like a nice evening to me, honestly. But yeah, see you guys next time. Let's see if there's any Godot devs online. Thank you guys for coming. I'm gonna go get some butter chicken. Damn, that sounds really good. Some butter chicken. Chance of center. Ooh. There's quite a few people. Huh. Narrative game. Let's see what this game is about.
Calculus to have it calculate the correct answer.
Let's check them out. Alrighty, guys. Thank you, J Rascal. J Rascal, for continuing that sub. Alrighty, guys. Let's set up this raid. And is the raid setting up? Did I do it right? Why? I think something's busted. Let me try to do it here. Okay. Alrighty, started it. Alrighty, guys, I will see you next week. Hopefully I'll get some Lawcraft stuff done over the weekend and I'll have something to show on Tuesday. But I'm really stoked with all the progress that we made. Alrighty, sorry it takes me like 10 hours to do normal things. Peace out, guys. Have an amazing Friday. See you next time. Bye.